We will start the second session of the day this afternoon with our archaeologist, Geoffrey Killen. Geoffrey Killen is a leading Egyptologist, wood technologist and furniture historian. He studied design and technology at Shoreditch College from the University of London and completed his PhD on woodworking of the Ramesside period at the University of Liverpool. Geoffrey has more than 40 years of experience of research on the area of ancient Egyptian furniture and woodworking technology, and has written several books, including Ancient Egyptian Furniture. The third edition was published in 2017, and Egyptian Woodworking and Furniture. His last book, dedicated to the TT3 furniture, will be published very soon by the Griffith Institute. I'm very pleased to welcome you, Geoffrey, today, and I leave you the floor for this amazing conference.
Hello, can everybody hear me? Well, as it's been said, I started this journey about 50 years ago, in 1973, when I went to the British Museum as a young student to look at the Tutankhamun material that was there on exhibition. I was blown away by the quality of the furniture, and then in my final year at the University of London, I was asked to write some aspect of a dissertation about some aspect of craft history. Well, I automatically thought, yeah, I'll do something on Egyptian furniture. So I looked. There was no resource material. There was archaeological excavation materials, but there was no books. So I then went back to the British Museum and I asked them if I could study the collection in the British Museum. And Mr. James, who was then the curator of the Egyptian department, teamed me up with Vivian Davis, you probably know. And we spent 6 weeks looking at the furniture and the woodwork in the Egyptian Museum, in the British Museum, and I wrote my dissertation. The dissertation was won the college prize, and it was seen by the editor of the Woodworker magazine, who serialized it way back in 1975, 1976, and it just so happened that Professor Smith at UCL was an avid woodworker who actually read the Woodworker magazine. And so he got in touch with me and asked me if I would be prepared to write a book for Harrison Phillips. He was the general editor of the Harrison Phillips books. And I did so. So that's where we started. Then I sort of transferred and went into Egyptology and studied at the University of Liverpool. So that's my background. So we're going to now move on. Unfortunately, the topic today, which is materials, tools, and non-textual methods, is only a very small portion of Egyptian woodwork, which is vast coffins, furniture, woodworking joints, different types of furniture. So I cannot cover everything in 50 minutes. So it is going to be a bit of a canter through the actual material. My friend here, he's followed me around for the last 50 years, and I now look like him. So Mr. Nebamoon, I salute you. Right. Good afternoon, everybody. I'm pleased to be here today to discuss the materials, tools, and non-textual methods that Egyptian carpenters employed to work some of the most marvelous artifacts produced in the ancient world. However, firstly, I'd like to thank Jazand and Carlos and the team here at the university and the sponsors for inviting me to give this keynote speech. Now, this talk complements the wonderful exhibition that we saw yesterday, looking at trees and beyond in Egypt, that we went and looked at, that is by Patricia Moray. Now, Egyptians exploited all the products of the tree. Its timber for constructional work and decorative work, its leaves for fodder, basketry, and matting. Apart from being used as a fuel, acacia, which is a very hard and durable timber, was worked into coffin parts, used in larger sections of roof sections and roof beams, carved to make headrests, used to make furniture, and has even been found in parts of chariot construction. It was used to make chisel handles and was widely used in the boat building industry. It's a fairly small tree with red-coloured hardwood. It's a hardwood. Its blossom being used for garlands and floral collars. The sycamore fig, not to be confused with the sycamore tree, which is a completely different tree, is recognized by its massive lateral curved branches, and it produces a pale light timber which has a coarse grain and is often of poor quality. Nevertheless, it was employed in the manufacture of rectangular coffins, as can be seen in the coffin of NENU, where we can see that the sycamore fig planks follow the curved profile of the tree's lateral branches. The Don palm, which is a very hard wood, was used in the boat building industry and general carpentry. And another native timber to Egypt, and used by the Egyptian carpenter, was the Ziziphus spinia Christi, which is also commonly known as Christ thorn or zidder. And it was used in the manufacture of coffins, dowels, furniture, and bows. Now, scenes showing woodcutters are occasionally found in relief and in paintings throughout the dynastic period. And in this illustration from the Old Kingdom tomb at Giza, we can see a woodcutter felling the tree. He has chopped a deep notch in the base of the trunk, and the tree is falling away from him. This is very unusual. Why? Because the tree should be falling towards him, because the notch has been cut in the front of the tree. Now, this perhaps indicates that the person who actually drew and painted this scene it wasn't fully explained to him, or the artisan who rendered the scene. So we have a disparity here between being told to do something and actually doing it, but not actually understanding the complete process. Now, tomb relief fragments discovered at Giza show clearly the dimensions of felled timber. An overseer is shown supervising men who are removing a branch from a trunk with axes. In the mortuary temple of Hatshepsut are punt scenes which show Egyptians and Africans cutting branches from what is thought to be African blackwood. Now, this particular tree is not the truly black Diosporus, which is Indian ebony, but Dalbergia melanoxylon, which is a very hard wood whose grain is black to brownish red in color. And African blackwood was used in furniture production, particularly in the manufacture of round-legged stools, and was used as a veneer to cover poor quality wood. Now, with demands for better quality timber, the coniferous wood trade from regions north of Egypt was well established by the 4th dynasty. The Palermo stone records that 40 ships sailed to the Lebanese coast of the Levant, where trees such as cedar were felled, and these were rafted and towed around the Mediterranean to be stored in timber yards in the Delta. Now, the Lebanese cedar, and this example is in the Botanic Gardens in Cambridge, is a very large tree growing between 30 and 40 meters in height, with a trunk of between 1 and 2.5 meters in diameter. It's a wonderful timber to work, for it's straight grained and takes a really good polish. It has a pinkish brown color and is very durable and is sweet smelling. It was widely exploited and was used in the manufacture of Khufu's funerary boat, in coffins and in shrines, and many of the pieces of furniture discovered in the tomb of Tutankhamun appear to have been manufactured from this wood. Now, the care in which timber was felled, so preventing the possibility of splits or thunder shakes, being impacted into the grain is seen in a relief on the northern exterior wall of the hypostyle hall in the Great Temple of Amun at Karnak. Here we have a photograph and a line drawing of the same scene. Woodcutters are shown felling a tree. One man is using an axe at the base of the trunk, which is shown by the red arrow, while two others are holding the tree with ropes, which have been tied to the uppermost branches, and these are shown as two blue lines. Now, this allowed more control over the speed and the direction of the tree's fall. Other imported timbers included the ash. Because of its elastic properties, it would have been used to make the halves of tools, as well as chariot parts and furniture. And the list of timbers used was extensive. Egyptian carpenters readily embraced any timber and quickly learned how to exploit the diverse range of physical properties they exhibited. In understanding these characteristics, they were able to select the timber that would be needed to satisfy the needs of the product they were asked to manufacture. Now, not only is the felling of timber an important process, but its conversion into boards has to be done promptly in order to prevent defects such as splits and shakes developing in the timber surface. Now, these are splits in the timber that open into holes, either radially from the center of the trunk or around its growth lines or growth rings. In Egypt, long planks were split with axes and wedges from the trunk, which made the selection of straight-grained timber with few defects by woodcutters a vital process. The technique is known as cleaving and was well understood and practiced from as early as the pre-dynastic period. We find examples of crudely constructed burial boxes made from irregular shapes planks, which are all pegged together, and an experienced craftsman could split a trunk of straight grain growth into thin planks with ease. In ancient Egypt, timber conversion was also achieved by saw, and the felled log was bound with rope to a vertical sawing post. Therefore, accurately sawn planks were normally not greater in length than the height of the sawyer. Now, this scene shows a stone-weighted lever tightened the ropes that held the workpiece to the sawing post. The sawn conversion of green timber, now this term indicates that the timber is freshly felled and water is still trapped in the cell walls and cell cavities, would cause the saw to jam, and wedges were employed to keep the kerf, which is the saw cut, open. From planks of timber which make the carcass of early dynastic coffins, it's clear that the early sawn conversion of timber was a difficult process to achieve, with only the small hand saws that had been developed and were available. The saw lines run across the surface of these planks in many directions. An excellent illustration of the saw being used can be seen here in the 5th dynasty tomb of Ti at Saqqara. The quality of sawn timber improved by the end of the Old Kingdom with the introduction of the large pull saw. Now, this saw can be distinguished from the hand saw because it is usually manufactured without a wooden handle, which would have been pulled off during the cutting stroke, for its teeth pointed towards the sawer. Now, the process of reducing the moisture content of green timber is called seasoning. Planks which have been prepared by through and through cutting, either by sawing or cleaving, shrink on the face furthest away from the pith, the center of the tree, than the face that is nearest the pith, which is much drier. Therefore, the drying of planks is another important process, for if it's achieved too quickly, the planks are likely to warp or cup. Those boards prepared by through and through cutting exhibit on their surface the typical slash grain figure. And I was interested this morning seeing some of the roof beams, painted roof beams, that show this type of grain structure, through and through grain structure, because timber can be cut not only by through and through methods, but by radially cut as well, which produces a different grain structure on the surface of the timber. Now, in the next section of this presentation, I'd like to look at the tools that were used by the ancient Egyptian carpenter. By the New Kingdom, the range of woodworking tools were available was quite impressive, as shown here and over there. However, those indigenous timbers used during the pre-dynastic period were worked with simple flint knives, some of which had serrated edges, which made them perform like a primitive saw. At this period, there was little demand for imported timbers. Now, this changed with the introduction of specialised copper woodworking tools at the beginning of the early dynastic period. This new technology created opportunities for resistant materials such as timber and ivory to be worked to a high degree of accuracy. And a fine collection of woodworking tools was discovered by Professor Emery of University College London at Saqqara in tomb S3471. With the forged copper handsaw, it became possible not only to convert timber into boards, but to cut these boards to various lengths across the grain and to form sophisticated joints in them. Now, these simple saws were developed from the copper knife and were between 251 and 400 millimeters in length. Their teeth were irregular in shape and pitch. That's the distance between each tooth. And the set of these teeth were all pushed to one side, unlike the alternating set of a modern saw, where each saw tooth is pushed either to the right or to the left of the blade. Now, this made the ancient saw difficult to use, as one side of the blade was always in contact with the wet and resinous saw cup, which is known as the kerf. Now, we see the introduction of small copper chisels at this time, and these were designed without handles and were used to chop wood, holes in wood, and also in stone and carved stone. And it also has the ability to cleave timber and to cut it into using these early copper tools. It's possible by the early dynastic carpenter to make simple jointed frames, a design concept that could be easily adapted to them for the manufacture of bed frames, stools, boxes, and coffins. Development in tool design and technical processes rapidly emerged as carpenters realized the potential of the medium they worked. Better quality timber required better quality tools, and this created better quality work. By the 4th dynasty, carpenters were experienced practitioners using a range of sophisticated tools. Their working practices can be analysed and understood through tomb wall scenes, such as those tombs of Rekhmire and Empuy at Thebes and Ti at Saqqara. From the 18th dynasty tomb of Rekhmire, we see a number of carpenters engaged in a range of woodworking activities. One scene shows the conversion of timber using the saw. A tree trunk has been sawn and it's lashed with rope to a sawing post. Noticed by the New Kingdom, the stone lever weighted mechanism that was seen on earlier conversion scenes has been discarded, indicating the saw perhaps is now running through the timber without jamming. In the Metropolitan Museum of Art, we have a similar saw that can be seen in the tomb of Rekhmire, while in the British Museum we have a full-size pull saw used for the conversion of timber, shown in the red outline box. With this saw, the saw teeth point towards the sawer. The cutting stroke is on the pulling motion of the saw, and this prevented the saw from bending as it was pulled through the timber. Notice in the top left corner of this scene, we have 2 sawn boards, shown in the blue outline box. Each display the typical slash grain figure achieved by through and through cutting. And are these boards that have been rendered here by the artist showing us that the boards are actually now being cut and seasoned? Another scene in the tomb at Rekhmire at Thebes shows the importance that carpenters placed in the measuring and setting out of timber. The carpenter sits at a block of shaped stone and works at a wooden bench. There's a rebate cut along its front edge. The Egyptians never had the vice, so they had to have this rebate on their benches. This rebate was designed to allow him to firmly hold the workplace to the bench while it was being sawed across the grain to the desired length. He uses a straight edge or cubit rod to measure and test that the timber element he is working on is true and flat. The cubit was a unit of measurement that was 524 millimeters in length, approximately the length of a man's forearm from the tip of his middle finger to his elbow. The measurement was subdivided into 7 palms, with each palm subdivided into 4 digits of thumb width, making 28 digits equivalent to 1 cubit. He also uses a tri-square to test that each sectional corner of a plank or batten is exactly 90 degrees in profile. We can also see that he employs a mitre square to check and mark out angles of 45 degrees. And this unique example is preserved in the Petrie Museum of Egyptian Archaeology at University College London. Now, he embeds the blade of his adze in the top surface of the wooden bench. Sharp tools on the workshop floor would have been a serious injury risk, particularly with bare feet. The adze was used to true and shape timber, and the shape of its metal blade developed throughout the dynastic period. During the early dynastic period, adze halves were straight. However, by the later dynasties, as in this slide, we can see adzes with shaped halves. Another woodworking scene in the 19th dynasty tomb of Ipuyi, TT217 at the el-Medina, shows carpenters building a catafalque. One carpenter is seen working on the roof of the catafalque. He is shown chopping a hole in the edge of the roof's cavetto cornice with a mortise chisel and mallet. The mallet would have been made in one piece from a dense block of wood. The metal mortise chisel is now held in a wooden handle. The purpose of this type of chisel was to chop and leave pieces of wood out of square or rectangular holes, which are called mortises. Another carpenter is shown carving grooves on the inner surface of the roof's cavetto cornice. Here he uses a different type of tool or chisel, a firmer chisel. He uses it by using it in his hand to carve the surface of the cornice. The firmer chisel was designed with a wide flare cutting edge that was wider than the bar from which it was forged. Cutting edges could be modified to suit the needs and profiles of what particular product was being manufactured or carved. In the Old Kingdom tomb of Tea, we also have additional evidence of the tools and processes used by carpenters at an early period in this beautifully rendered scene. Within the scene, we find a carpenter using a bow drill to bore a hole in a piece of wood. And here we have the first illustration of the bow drill being used. The carpenter holds the bow in his right hand, and the bow cord is wrapped around the wooden drill stock, which he holds in his left hand with a hollowed out stone or nut cup. This was the bearing that he used to hold the spinning drill stock. The metal bit is fastened into the bottom of the drill stock, and the bow is drawn backwards and forwards in a reciprocating motion and bores a hole in the workpiece. One of the earliest surviving examples of a bow dates to the 12th dynasty and was discovered at Lahoun. Now, this particular bow was used in a fire lighting stock, but we also have an example of a New Kingdom bow and drill preserved in the British Museum, London. Professor Emery also discovered in tomb S3471 at Saqqara a number of thin blade oars similar to this New Kingdom example. These could have been used to bore holes in wood or produce a mark in which the drill of the bow drill could be located prior to drilling. All these tools would need to be sharpened at regular intervals, and the carpenter's workshop was equipped with a small forge where blades could be reformed and heat treated. The final sharp edge was then ground onto the blade. Now, this process was achieved by honing the blade at an angle on a whetstone with a little oil. And this whetstone has a hole bored through it at one end. And to help lubricate the whetstone, oil from a flask was applied to the surface. and at one end is a wooden stopper, while at the other is a wooden spout formed in the shape of a spoon. Tied around the spout can be seen some cord, which perhaps indicates that it was hung on a peg somewhere in the workshop with the wet stone. A further scene in the Tomb of Tea illustrates the sanding of wooden boards. When finishing and smoothing wood, carpenters used abrasive stone blocks, which they rubbed along the grain. Now, in the Tomb of Menkaure at Thebes was discovered a model of a carpenter's workshop. It's in Cairo at the moment. These Middle Kingdom carpenters are shown engaged in many activities: truing woods with adzes, mortising with chisels, and converting timber with a pole saw. It appears that the carpenters are working on a type of batch production process, where one man repeats the same process. At the far end of the workshop can be seen a large white chest in which the tools were stored. To the right of this is this chest is in the corner of the workshop. A group of men are huddling around a small forge. They are heating and sharpening the tools that have been returned by the carpenters. Now I would like to look at secondary processing of wooden products. Egyptian carpenters began to laminate thin sheets of timber as early as the Third Dynasty in an attempt to fabricate large sheets of material which was dimensionally stable and equally strong in all directions. An example of 6-ply wood, where the grain of one sheet is at right angles to the next, was discovered in a sarcophagus within the Step Pyramid complex at Saqqara. Carpenters were also experienced in artificially bending green timber, and at Beni Hassan we have a scene which shows a Middle Kingdom carpenter steam bending or wetting a length of wood, while a second carpenter is shaping the soft timber by pressing both ends into the ground. Once the wood had dried, it retained its desired shape. Now, the art of rotating timber between fixed centres and scraping the wood away was known to Egyptians. Evidence of small-scale turning can be found on a few stool legs, which date to the New Kingdom. However, the majority of round-legged stools of the early New Kingdom are neither turned nor hand-worked between metal centres. The lower right-hand image, marvellously recorded by my wife, captures 5 profiles of the same leg that has been rotated through one revolution. It shows that the leg is irregular in profile and not circular. The red arrow indicates a clear bump on the foot section, which would not be there if the leg had been turned. Additionally, the leg shows no evidence of being supported between pivotal centres, and those lines which are incised about it are uneven. The shoulder at the top of the leg is not machine square, and a spike seen is not seen on turned legs, extends from the top of the leg, but it would be jointed into a hole in the underside of the seat frame. Now, the first illustration of carpenters working on a lathe is seen in the Greco-Roman tomb of Osiris at Tunur-Gebel. The wooden bed of the lathe appears to be vertically mounted and firmly set into the ground. Now, the wall relief has possibly been rendered in this way to give a clear impression of the process. In reality, this lathe was probably used horizontally mounted. However, some stool legs and other artifacts that date to the Ramesside period exhibit true turning, such as a pair of stools preserved in the British Museum that have been carbon dated and found to be manufactured at the end of the New Kingdom. One is in fragmentary form, which allows us to examine its construction in detail. The top of the leg to the stretcher's mortise has been turned parallel and then smoothed with sandstone. Below the stretcher joint, the leg has been turned to a simple spindle shape. And as part of my research into how this leg was manufactured, I built a horizontally mounted leather strap lathe and proceeded to turn parted sections into a rotating blank. This technique successfully worked and created a parted section in the blank that would have been difficult to cut by hand. A second stall preserved in the British Museum is almost in perfect condition. We can clearly see the pivot marks under the legs, although much worn due to the stall's use. It is similar to the first stall, and the spindle work below the stretcher joint is very accurate, the profile being well formed and symmetrical. Also in storage in the basement of SACE, the School of Archaeology, Classics and Egyptology in Liverpool, is another fine example of a turned piece of wood. And here we can see the pivot mark, which is greatly magnified in the image, has evidence of burning deep within the pivot, and that indicates that it was creating friction as the time it was being worked, and it was set onto a metal center. Now I'd like to look at some of the ways which Egyptian carpenters embellish wood. The 18th dynasty carpenter scene in the tomb of Mire at Thebes also shows a carpenter applying hot glue to a leaf of veneer with a brush. The glue was made by boiling down the skins and bones of animals and allowing the solution to concentrate, leaving a concentrated viscous adhesive. Veneer was used as a decorative layer to disguise poor quality wood. Decorative wood veneers were cut with a thin blade saw, unlike the modern process of slicing or rotating a log against a fixed knife. Large amounts of ivory strip that have been incised with twisting, crossing, diagonal chains, zigzag patterns have been discovered at a number of early dynastic sites and were dowed to furniture in an early attempt to veneer them. The Ashmolean Museum in Oxford has an excellent collection of ivory strips. Many New Kingdom boxes were made from solid boards. The underside of this lid is made from 2 solid boards. However, the upper surface, as well as the box's sideboards, have been edged with African blackwood veneer in an attempt to give an impression of a rich frame, while the imitation panels were covered with tiles of faience and red-stained ivory, which were separated with ivory and blackwood stringing. Many of the rectangular boxes discovered in the tomb of Tutankhamun were surface treated in a similar fashion. The technique of inlaying, that is embedding a variety of materials into wood, was widely practiced throughout the dynastic period. And this lid from Abydos has one surface inlaid with triangular pieces of wood and faience. A number of pieces of furniture discovered in the tomb of Tutankhamun were decorated with applied techniques of marquetry and parquetry. Now, marquetry is where shaped pieces of wood or ivory have been applied to the furniture surface to create possibly a picture, whereas parquetry, as illustrated in this slide, involves applying thousands of individual pieces of wood and ivory to create different geometric patterns for the decorative surface finish. The technique of staining ivory to produce pictures on furniture was also commonly employed. These slabs of ivory would have been attached to the sides of the box with copper nails and were carved in bas relief before being stained with a floral, animal and hunting motifs. Gilding was another popular technique applied to wood. One of the earliest examples of this process is seen on the reverse side of the lid fragment we previously examined from Abydos. The edges of the fragment are carved with a bound rush pattern commonly used at this period. The surface was overlaid with fine linen, onto which the gold leaf was applied and brushed and burnished into the bound rush pattern. Only small amounts of gold can now be seen on this fragment, indicated by the red arrows, in the crevices of the bound rush decoration. Gesso paste was also used as a bonding medium to hold the gold leaf to the wooden core, and this technique was used throughout the dynastic period and is seen on much of the royal furniture discovered in the tomb of Tutankhamun. We also see the use of thicker gold sheets and sometimes silver beaten, pressed and punched onto and around wooden cores, and these metal sheaths were held in position with small nails. And this wonderful example has recently been reassigned to have been discovered in the tomb of Ramesses IX. From the earliest period, the concept of constructing wood using woodwork joints is in one of three conventional forms: the box, the frame, and the store, or a combination of them are using joints was established. And these constructional systems were found to exploit the physical properties of timber. Firstly, is that the wood strength is always along the grain and not across it. And secondly, that the shrinkage of wood is negligible along the grain. A selection of commonly used woodworking joints used by Egyptian carpenters can be seen in this slide, but unfortunately I cannot go into any detail about how these joints were used in this presentation. Another major shift in woodworking technology occurred with the introduction of iron woodworking tools. Again, Egyptian carpenters embraced this imported technology from the Roman world and used it to meet the cultural needs of Egyptians now living in a Greco-Roman society. A thriving woodworking centre developed in the Fayoum to meet the needs of those people living there who required a new form of burial practice, that of having their living portrait painted on a thin veneer of wood that was then bound in on their death into their mummy bindings. Now, these veneers, many of which were discovered by Petrie, have become to be known as mummy portraits. Now, I've been involved in the research program at Fitzwilliam Museum in Cambridge that explores how these wood veneers were cut prior to applying the painted portrait. Now, this portrait of a bearded man indicates that it's manufactured and painted mid to the late 2nd century CE. Analysis has shown that it is only 2 or 3 rings, tree rings in thickness, averaging no more than 4 millimeters in thickness, and was cut from a block of lime wood. Viewing the back of the veneer now shows that it is split along the grain and is held together by 2 pieces of Victorian tape. The back surface shows that it was sawn across the grain with a very long bladed saw from the block of lime wood. The saw lines run now parallel to each other and could not have been achieved by those previously discussed hand and pull saws. Now, this leads us to look for evidence of new saw technologies being used as for carpenters now working in the Fayum for their mummy portrait boards. Petrie was also to discover the woodworking tools used by the carpenters, and we see a new range of iron tools that were being used, including an example of a long iron frame saw. As part of this research, I manufactured a replica frame saw based on a woodworking scene found at Pompeii. The saw blade is anchored to the replica wood frame with a tightening mechanism that grips a hole at each end of the blade. The woodworking scene at Pompeii shows a frame saw being used by 2 people to saw a plank of wood. Preserved in the Petrie Museum of Egyptian Archaeology at University College London is a broken iron frame saw blade, and with the wonders of computer technology, allows us to bring the 2 broken fragments together. And although the iron frame of the saw is badly corroded, it still retains a sharp saw blade and teeth, and there is a hole at each end of the blade that would anchor the blade across the wooden frame, as previously seen on my replica frame saw. And in order to cut thin veneers of this type using this saw, a sawing guide may have been used or employed to prevent the saw blade from breaking through the surface of the veneer as it was sawn from the lime block. Another mummy portrait preserved in the Fitzwilliam Museum, Cambridge, shows the likeness of a woman. Again discovered by Petrie, it is also made from lime wood. The back surface of the veneer has several large patches of dark resin and pieces of textiles attached to it. However, the tool marks left on the back surface shows that this veneer has been worked thinner with the aid of a woodwork plane. There are narrow parallel plane blade marks running along the grain. And you can even see there is in the plane blade, there are a couple of nicks in the blade, which has left ridges on the veneer surface. A number of woodworking planes have been discovered at Roman sites. Two notable examples in Britain are planes from St Albans and Silchester have been discovered at Greco-Romano British excavations. Now, these woodwork planes would have been made with an iron sole and would have been riveted to an ivory or wooden body. The iron plane blade, also known as the plane iron, was fitted into a hole through the plane body and was then locked in place with a wooden wedge when the required depth of the plane blade was exposed below the sole. Now, finally, I would like to examine some non-textual methods Egyptian carpenters employed to express their ideas and manage their working practices. Now, we have evidence from two sheets of papyrus from Guru that date between the New Kingdom and the Ptolemaic period that show Egyptian carpenters often relied on accurate working drawings. This is unusual because there are not many of these drawings around. Each sheet conveys information in orthographic projection that shows either the front and side elevations of a wooden shrine at half full scale. Now, this working drawing, which I think is unique, shows the side elevation. This particular one shows the side elevation of the shrine. It is drawn in black ink on grid lines. The details are precisely drafted. The draftsman is giving precise details about the form and parts that need to be manufactured to realize the design. The internal panel box construction of the inner shrine is held together with mortise and tenon joints, and this inner box has a shrine-shaped roof that is supported on a cavetto cornice. This inner shrine is designed to be protective from the larger external frame, which has a large shrine-shaped roof and cavetto cornice, on which is mounted uraeus, finial, part of a frieze of uraei that had been placed above the shrine's entrance. Both the inner and outer frames appear to have been attached by a series of twisted rope ties, which possibly acted as a type of shock absorber to help when the total assemblage was transported. The length, diameter, and angles of the surrounding poles and the terminals provide enough detail that, together with the data supplied on the second papyrus, would have allowed the carpenter to build this shrine. Clients could also be asked to provide details of a commission, which could involve providing sketches or measurements for the work they wish to undertake. One letter provides measurements to make a commission. The unnamed client stresses that he urgently requires 4 identical frames of 4 palms in width and 5 palms and 2 digits in height. The drawing of the frame is in orthographic projection, a rectangular form filled with 2 horizontal rows of 8 vertical bars or panels separated by a horizontal rail. The size and form of this commission may indicate that it was either a hinge window or a small door. We also have a number of ostraca, which have illustrations of wooden objects and other non-textual information. They are commonly referred to as furniture ostraca, and O Florence 2628 is the most detailed of these furniture ostraca. Several elaborate pieces of furniture and coffins are listed in 4 lines separated from each other by thick black strokes. For example, in the first line, we see a lion-legged chair, number 4, and the seat being supported by a single horizontal rail and braced with a vertical strut and 2 diagonal bars. On the same line, we have an illustration of the side view of a box. An actual box of similar design featured here was discovered in the tomb of Sennacherib and is preserved in the Metropolitan Museum of Art. in New York. Now, together with Laura Weiss, we examined some detail from these furniture ostra preserved in the Egyptian Museum, Florence, and our findings were presented in markings on daily objects and use of from el-Medina ownership marks and administrative aids. It appears at el-Medina that existed a system of hieroglyphic and abstract marks. And I have a copy of the paper over there if you would like to look at it, that you can consult to look at our findings. Now, these marks on both ostraca and other objects used as part of daily life. And interestingly, some marks on ostraca are linked to furniture illustrations, and the paper analysed these marks and the importance craftsmen placed on various marking and drawing conventions as a non-textual method of presenting and communicating information in a visual form. Now, in this very short presentation, I know it's a 50-minute, but in this very short presentation, I can only give you a brief review of our findings. For example, we see a Gardner F31 sign, and without the stroke below this sign, it's well attested as a workman's mark referring to Mez of the 20th dynasty. It would also appear that this workman with others shown as signs in the second register of this ostracan were part of a team responsible for the manufacture of furniture and possibly the painting of furniture. And in this slide, a Falcon sign, Gardner G5, is well attested to referring to Mina or Hor of the 20th dynasty. The ostraca can also present signs which we believe to be quality marks. And here, a bed frame has been awarded a 5-star or 5 Nefer quality mark, a recognition of the finest quality that could be manufactured. 5 good stars, an average version of our modern Trustpilot reviews and ratings. It is noticeable other pieces of furniture are rated of far lesser quality, 3 or 4 good Nefer quality marks. Without doubt, more work needs to be done into these aspects of communicating ideas and data. The Egyptian carpenter used an extensive range of woodworking tools. The quality of his work was judged, and he was skilled in many woodworking processes. The processes and techniques of working wood that were developed in antiquity are still used today by carpenters who have passed down from their master to apprentice and continuously practiced through the last 50 centuries. Hopefully, with the age of computers, AI, and computer-generated machines, young children and adults will still be able to work wood with modern replica tools and hand tools that were developed in antiquity. And in Egypt, this is actually happening. An exciting cultural heritage program where I am members of the Fitzwilliam Museum Coffins team together with Amorenza and Sarah Haney of Pinocchio Furniture and Wasla, have been working with carpenters, school children and students of art and design colleges in Demetia, Egypt. Demetia is the foremost furniture centre of Egypt, and most of its population rely on the furniture trade. Indeed, the popularity of these events is demonstrated by such an event was organised in the newly opened Grand Egyptian Museum in Cairo, which also has a tactile and handling area in its innovative Children's Museum. Thank you very much.
So we are starting our final session. It's a bit sad. I mean, after this day and a half of fantastic lectures and discussions, now we are approaching another important aspect of interconnectivity. We talked a lot yesterday and also during the morning session about text, objects, people, profession, that any of this aspect or all of them cannot stand alone, that everything is interconnected. There have been also every now and then mentioning of networks, and to think about network is an important step toward applying the network theory, social network analysis, and other tools linked with the network theory. So our final session are discussing some possibilities and limitations of the network theory, whether we are talking about geographical aspect or spatial aspect or temporal aspect or the basic form of network approach, in fact, the connectivity among humans. Within this section, we are having 6 colleagues working not just with Egyptological material, but also with the broader archaeological context. And our first speaker is Luisa García González, presently affiliated to the Northeast Normal University Changchun in China. Luisa is a former Margarita Salas postdoctoral research fellow and visiting researcher at the University of Belgrade and also University of Alcalá. And presently, as I said, she is a visiting professor at Northeast Normal University in Changchun in China. Luisa is a deputy director of the archaeological mission of the Kubet El Khaba project. She specializes in local Egyptian administration, prosopography, material culture, burial customs, memorial culture, and social network analysis of the first intermediate period and the Middle Kingdom. Luisa, good evening. Do we have you? Microphone. Luisa? Unmute yourself, please.
Now? Yes.
Okay. Good evening. I guess.
But I was sorry.
Okay?
I was sharing the screen, and now I don't know what I did it, but it's not. I'm going to leave it. Sorry, Daniela, for interrupting
No, it's okay.
you.
Okay. Just adapt your presentation. No problem.
Now I think I'm presenting.
Is it okay?
Yes, you can see, no, the what I'm sharing.
Yeah, we are seeing you and hearing you, and the floor is yours.
Thank you. Thank you very much, Daniela, for your warm introduction. And I would also like to thank to the organizers, Gigi and Carlos, for inviting me to this conference that I wish, of course, I could be there with all of you, sharing and enjoying that scientific, academic, and joyful atmosphere that I know that this kind of events usually create. But anyway, thanks to technology, I can somehow be there and share with all of you the work I'm going to present, and even if I'm thousands of miles away from Alcalá. So as the title of my presentation indicates, what I'm going to present today is just the preliminary results of the first tests made on the application of social network analysis as a complementary approach to the study of the coffin texts appearing in Egyptian Middle Kingdom coffins. First of all, I would like also to clarify that this is a research line quite new for me, not only in terms of methodology, but also in terms of the issue under discussion, in terms of the coffin texts. So let me explain briefly why and how this topic came into scene. I don't know if this is working. Yeah. So During my predoctoral research, I focused on the prosopographical study of the Middle Kingdom local elite from Elephantine, the capital of the first nome of Upper Egypt, in connection to my work as a team member of the Kubet El Hawa project of the University of Jaén. This research permitted to connect well-known monuments from the Theban nome to Elephantine. And one of the research lines proposed for the postdoctoral phase, once I finished my thesis, was to delve into the digital humanities as an axis to undertake archaeological research in the future. So during my most recent postdoctoral phase that Danijela has mentioned, I carried out a research based on the application of social network analysis to the prosopography of the local elite from Elephantine. So I was connecting the predoctoral research. And to do so, I undertook a research stay at the University of Belgrade under the supervision of Daniela Stefanović. There, I learned the basics of the SNA methodology, the SNA as the abbreviation of the social network analysis, and the Gephi software. And first tests and graphs were created. Hence, a first contact with the methodology was being already undertaken, and the primary results of this outgoing phase of the research were published as an article and presented in a conference last year, and another contribution is currently in press. My second year of this fellowship was done at the University of Alcalá, and this is also a turning point for this research I'm going to present, under the supervision of Carlos Gracia Zamacona. And then I was included as a member of the research project he's leading, the Mortuary project. This project focuses on the mortuary texts of the Egyptian Old and Middle Kingdoms, covering a wide chronological range of almost 1 millennium. However, what is truly innovative about this project is its digital nature used for the execution of the work, and the primary achievement of that was perhaps the creation of the Mortexbar online database. The analysis of the variability of these texts is being carried out using electronic tools that I guess that we will also see after this presentation, and that shows and highlights the strong interdisciplinarity of the Mortexbar project. In the search of and determination of an efficient action plan during my stay in Alcalá, we both, Carlos and me, consider the possibility of drawing a new work line, a new work itinerary, combining both research lines, the Egyptian mortuary texts from the Middle Kingdom, specifically the coffin texts on the one hand, and the social network analysis on the other. The result is a new research line as a part of the Mortexbar project. The objective of the current research was then to provide a new social perspective to the study of the mortuary texts, initially evidenced in the Egyptian coffins, wooden coffins of the Middle Kingdom, that is to say, the coffin texts, but also another linked artifacts from funerary context could also be considered. In an ambitious attempt to add new value towards a comprehensive knowledge of the topic, the research would make use of the SNA method through the use of computational tools. To accomplish that, two primary research objectives were defined at the beginning. To detect any social pattern or behavior in coffin texts through the analysis of their appearance on the coffins, and also to visualize the geographical dispersions of the coffin text throughout Egypt. That was the initial idea, but the truth is that limitations are usually present in any research process, but a good contingency plan may help us to prevent major inconvenience. One of the critical, constricting, and inherent points when conducting any research is the temporality. A primary contingency plan applied to this initial difficulty was to constrict the geographical provenance of the coffins of the archaeological sources. Instead of covering the whole Egypt, we decided to limit the geographical context to the 4 southernmost regions of Upper Egypt and leave the rest for a future, perhaps a project, if we can manage to find some grant or another kind of funding. I know that sometimes it's quite difficult, but for the moment, we will keep that option apart for the future. In any case, choosing this southernmost area was more connected to my archaeological background and was in consonance with the previous research, as explained before in the justification part. Still talking about limitations, also, I have to mention the level of knowledge or expertise as one of them. Regarding this, as I said before, I should say that I'm not an expert in coffin texts, and I consider myself an amateur in applying SNA methodology to Egyptology or to archaeological research. In fact, I'm still learning about the use of Gephi as a main tool to apply this SNA method, as well as other useful software that might be helpful in terms of expanding the research in the future. Like, for instance, using the software RStudio that I have the pleasure to attend a course last summer in Valencia with Joaquín Jiménez, who is going to also to provide a presentation later. Since our main objective was to detect any kind of social behavior or other kind of pattern or lack of that between the coffins, between the coffin texts, the coffins, and also the owners, and that's supposed to handle a relevant quantity of data, data mining was the procedure to undertake the research, which went through different phases. The first phase was the collection of data that has been made through 4 main sources. The 7 volumes of Adrian the book, in which almost 2,000 spells are listed in connection to with the coffins where these are mentioned. Also, the recent publication of Carlos Gracia Zamacona, where we could also find new sources appeared after the book's publication, the Mortexbar project, the Mortexbar, online database, in combination with other Excel files kindly provided by Carlos in order to make the data collection easier or even less painful, so to say. And of course, we also consulted the online database, persons and names of the Middle Kingdom and early New Kingdom, in particular to confirm some prosopographical details. The second phase of the data mining was to prepare the data set in order to be read by the computational tools. To do so, files in Excel were created in order to achieve the 2 main objectives mentioned before, and for each objective, 2 Excel files were created, one for the notes and one for the edges, that were later read and processed by Gephi. Gephi is a network visualization software that permits to visualize not only the networks detected from the data, but also their modularity or clusters. The data included in the Excel files were processed by Gephi using algorithms that permit to design and visualize graphs and obtain some useful metrics that could be later interpreted. As said before, we had 2 main research questions to answer. So we treated them as 2 different case studies in terms of data. Case study 1 addresses the relation between those solder coffins as archaeological sources that have potential prosopographical and social data and the spells. Therefore, a two-mode network of 332 nodes and 507 edges was obtained. As the two-node term indicates, this network is composed by two types of nodes. The coffins, identified in our slide in green color and being about the 8% of the total nodes, and the coffin texts that have been colored in pink by Geoffrey and suppose the near 92% of the total nodes quantity. Going further towards some metrics, we can mention that this graph has a low rate density, which means that it is far from being completely interconnected, since its edges are frequently just one direction. In terms of interpretation, the generated graph is indicating that four main actors are detected, and they are marked in the slide, in the graph. All of them are coffins belonging to higher Theban officials, and according to their rank, they got a relevant number of spells in their coffins, which means that they have high degree centrality. Although we cannot forget these three coffins in the upper part of the graph from Gebelein and Aswan. Although their owners had no titles, they were wealthy enough to command those coffins with a very extended and particular textual program on their inner walls. In fact, that is the reason why Geoffrey was somehow displacing them in the graph. In general terms, the spells written in these three coffins are hardly present in other coffins throughout Egypt. And therefore, the lack of sharing connections, or even better say, the lack of sharing edges, is translated as a lack of centrality, in contrast to the situation shared by the aforementioned Theban coffins, which are right in the center of the graph, as we can see. So Gebelein and Aswan coffins lost a central position, but still they have a high degree in connections in the network in general terms. In terms of clustering, 10 groups or clusters have been detected in this network. As we can see from the slide, there are two main clusters that have been marked with the circle. The cluster 1 is composed by 5 sources from Thebes. The cluster 2 is composed by those two the Gebelein and Aswan coffins, but 2 Theban coffins are also included in this cluster. Something to highlight is the fact that some coffins are their own cluster. That is to say, one coffin is one cluster or one group, which indicates their particularity in terms of textual program. We can mention cluster 3, 5, 6, but also 8, 9, and 10, these tiny groups. That even if creating their own self-group, they are, of course, less centered in the graph due to their low degree in terms of quantity of spells writing on them. Another clustering detail that I would like to remark is the position of the cluster number 7, colored in brown here in the lower part of the graph. This group is so far from the central area because it just only shares one node in as a connection with the whole graph. When this kind of situation happens, that is spell 362, this node is called a bridge because it's connecting different groups. The second objective of this research was to obtain a glimpse of the geographical dispersion of the spells throughout Egypt. For that, I focused this time on the locations rather than on the coffins. Hence, a two-mode network of over 1,000 nodes and almost 1,800 edges was obtained. Just to describe a bit the graph, the nodes colored in green are the locations, being less than the 2% of the total nodes, and those colored in pink are the spells, being slightly over 98% of the nodes. Its density is even lower than in the previous graph, indicating again that this is far from being completely interconnected. At a glance, I guess that we all may see, may realize that there are three main locations where spells are concentrated. Deir el-Versa here, Asyut there, and Thebes in this area. In terms of clustering for this graph, Geoffrey detected 9 groups of locations sharing spells and particularities. Cluster 1 is composed by only one location, which could not be other than the el-Versa. In the Middle Egypt, cluster 2 is the second denser group and is composed by Asyut and Heracleopolis in the northern Upper Egypt. Cluster 3 by Thebes and Setment, but also Balat is included in this cluster. Cluster 4 by Saqqara and Komel Hessin, and cluster 5 Meir and Dendera. Cluster 6 in red is composed by Gebelein and Aswan in the South Egypt, but also by Dasur, which is just connected by one edge. Cluster 7 is cluster 7 by List, Abydos, and the still nowadays unknown location, and cluster 8 by Beni Hassan and Kawel Kebir, and lastly, finally, cluster 9 is composed by Mendes in the Delta. From this graph, we can also realize the centrality of some spells. When looking in detail, we can see a mix of colors right in the center area, which means that those spells located there are very well connected to several geographical areas. So the variety of ties is higher than the median. The situation, that situation should be understood as a degree and centrality of these nodes, in this case of these spells, and the number of edges feeding these nodes are higher than the media, than the others, and for that they got a central position in the network. As we can see, spells 162 and 397 are slightly displaced of this triangle that I drawn as a central area because they are not connected to the el-Versa and nor even to Asyut in the case of 397, sorry. The lack of connections makes them a bit decentered in comparison to the aforementioned spells. Therefore, these spells might be considered as those more spread throughout Egypt. Just a short conclusion part. I would like to emphasize that even if the research is incomplete and still ongoing, and I am here presenting today rather a description of the results more than the interpretation of them, but even so, our two original objectives have been somehow achieved. It has been demonstrated how many data have been deduced from the implementation of SNA to the study of the coffin text. We have seen the potential of the method to do that through the use of digital tools like Geoffrey. This software provides us with certain metrics that will help us to interpret the data and the sources from a better understanding of them. More than a conclusion, that is, this is a reflection about the importance of networking, not only in terms of ancient materials and people, as has been demonstrated in this research, but also in terms of current new collaborations between scholars. These synergies open new research lines and that create interdisciplinarity, very much needed in research projects. Thanks to this new collaboration with the Mortuary project, a new research line was placed on the table, and it seems that it may give us interesting results and promising new interpretations of the coffin texts and coffins and people all interconnected. There are too many aspects that are still waiting for new research, and final conclusions will come up after a common reflection and interpretation of the results with the rest of the team, in particular with Carlos as the head of the project, but that will be presented in perhaps a second shaped edition of this conference, inshallah. So thank you very much for your attention.
Thank you very much, Luisa. It was excellent presentation. I know I should, but I must say that I'm very proud on you.
Thank you very much, Daniela.
Yeah. Okay, we are proceeding. Our next speakers are our dear host, in fact, David Fuentes and Carlos Gracia Zamacona from the University of Alcalá. David Fuentes is professor in electronics at the University of Alcalá. His research interests include computer vision and deep learning applied to biological signals, depth information, and deformable discrete surfaces. He has actively collaborated with researchers in various computer vision disciplines, particularly in people detection in depth cameras and the use of biological signals for dynamics and biometric analysis. Our dear Carlos is professor at the University of Alcalá and director of the Mortuary project. He is interested in empirical linguistics, graphemics, and text analysis. He concentrates on ancient Egyptian mortuary text from the Old and Middle Kingdom, and future is coming. We are combining Egyptology and engineering and biology. So, the floor is yours.
Thank you. Thank you, Daniela, for the presentation. Can you hear me? Yeah. Okay. So the presentation we have been working on for some months now with the electronics department in Alcalá starts with realizing the need to work with a big amount of data and how to do that. The problem with the coffin text, and not only with this text, is the primary context they were produced. We don't know very well, in many cases, what was the first context for this text. We know that they end in a coffin and they are used clearly for the deceased, but many of the texts come from another traditions, for example, magical spells or theological hymns. So this is one of the first problems we encounter when we try to explain how the coffins were produced, or how, if you want, how the coffins were edited, in the sense that we treat them as documents that have to be managed and they have to decide what text put in a coffin and in which way. The second problem we find is the opacity of the writing system. So we have a lot of information about the semantics with ideograms, with determinatives, but we don't have, as you know, much information about the grammar. And this is why we are all the time discussing about how many CGMF there are and participles and so on. And the third problem, which is quite obvious, but we have to say, is that we have no informants. So if we are dealing with a linguistic corpus as this one, we cannot verify our hypothesis with living people because it's an ancient language. On the other side, if we want to tackle these problems by annotating, and we have seen that there are many projects in Egyptology, in Assyriology, that are doing this way, it takes a lot of time to do that. So to annotate a corpus, to not only transliterate, but to lemmatize, to analyze grammatically, to make parsing, the combinations of words, to try to find out the structures that we are very much interested as linguists, to see when a CGMF comes with a preposition or with no preposition, this kind of matters. If we have to do that manually, relying on, I don't know, 12, 15, 20 people in the world, it's going to take ages to do that. So what are we trying to do this here in a way is trick the situation or to try a shortcut. What are the two possibilities we have been managing here? The first one is try to do an OCR. So to teach the machine to learn to read hieroglyphs. To read hieroglyphs means that the computer is able to recognize images and give a value to that. So we want to jump the first line, which is the transcription, to get the Gardner codes. We are working in that line, but in parallel, we already wanted to try a quickest shortcut, which is to apply artificial intelligence to a database, a traditional database. The traditional database is the MortexVar database. We have like 28,000 instances or sentences transliterated with a translation in French. Then we started to talk to the engineers, and they told me, yeah, that's possible. We can do that. We can try, to see what are the results. And then some deep neural networks have been applied, which are called embeddings and transformers. And here is when I leave the floor to David.
Well, the information that we have available is MortexVar. So we thought, okay, we have all the text jet process from Adrian de Bac and Leonard Lesko. We have around 24,000 sentences. And in this sentence, we have the transliterations and translations full in French and provided in English by a translator that could not be perfect. Okay, so we thought maybe if we use some modern techniques, we can extract some information that will be useful for Egyptologists. After that, we thought, okay, well, there is the NLP embeddings or natural language processing embeddings, which is a well-known technique in modern languages that could be applied to ancient languages too. The good part of this deep neural network that is composed by all these parts is that it's unsupervised in the train phase, which means that if I provide all this sequence of sentences, I can train it and obtain later some facts that could be interesting. For example, some semantic relations, some contextual relations that can represent all the corpus with only one representation that could let the Egyptologist to see, okay, maybe this is a relation between this word, and I cannot see because it's in the spell 1 and spell 500, which is difficult to relation. So we prepared two deep neural networks, one for translation and one for transliteration, to study separately, and after that, unify that. We have all these parameters. You can see that there's a difference between the two networks because these parameters depends on the vocabulary that the system estimates on translation and transliteration, which means that transliteration have a lot more permutations, variations, and what we can call vocabulary. And after that, what we need is to create this training set because, okay, we have 24,000 sentences, but we cannot produce only with that all the training set. We have to pre-process that to create what we call the context pair. In the context pair, what we are taking is one target word and a context that precedes that. For example, in this case, we have the Rosen sequences, and after that, what pair of context we extract. For example, for the Egyptians, for Egyptians, the Egyptian roads, and after that, it depends too on the window size of context. For example, we can include hieroglyphics or other words too. But to arrive in this post-processing, we have to use what we call vocabulary builder and context builder. With vocabulary builder, what we are taking is all the words or transliterations that we can find in our corpus. After that, with the context builder and using our raw inputs, we create all these word per context. And we have all prepared to train. Okay, after that, how we train our system? Well, our training strategy is what we call continuous back of words. What's in layman words mean that, okay, I have a target word that will be, for example, Egyptians, and I have to use all the context around this word in a predefined window to train my system. We define it a context of words of 4 words around our target word, which means that we will see 4 words in this side and on this side. After that, we find too that we will use 300 vectors of output, which is a generic number that defines word-to-vec architecture, which is the one that we selected. The reason to select word-to-vec architecture and not others is because it can train with this method that allows us to include the context specifically. For example, we tried to globe architecture, but the problem is that we sense that this context don't make sense in this case, and we have to depreciate. Well, when we train in the insights of our network, what we is doing is minimizing this loss function. This loss function implies that it's trying to see from its context to our target word how is relation, and it's trying to minimizing that. Well, after that, in our results, given that it's a little difficult to show all the quantitative results, we selected 6 words that we think that could be interesting, and we will show all the other words in blue color. Now you will see why. Okay, this is our results. We have 2 ways of results. The qualitative ones, what we need to reduce dimensionality, because we have to think that we have 300 vectors as our outputs, and this cannot be visualized by human mind. So we have to reduce this dimensionality to 2D or 3D, which is what we can interpret in terms of distance or relations. In 3D, we have this sphere or something like that. And in 2D, usually, we saw something like an ellipsoid. Here, we can see the relation of these words. For example, this accumulation of points, now we will see what mean, and these points to very near. This is in the qualitative way. This will be quantitative. No? In the quantitative way, we have to use a similarity measurement between these vectors. We have to see if they are related or not, because this similarity will imply that in contextual terms, they are near in the corpus or in the information that we use. For example, if we interpret this score, 1.0 indicates maximum contextual similarity, what, for example, could be Horus and Osiris that are very related. If we have 0.0, we don't have contextual similarity, which indicates that these 2 words are not alone or no relation. And finally, we have this similarity. That is very strange in our case because we don't optimize that, but could appear. Okay, if we see our representations, in this case of translation, we can see, for example, that in the case of Seth, Osiris, Horus, and Isis are very near, while Geth and Thoth are farther from them. This indicates that they are very relation. All these blue points are words that represent Mortexvar entirely.
Yeah,
Well-
well, the schema, we can see in the diagram that things that we know. We know that Osiris and Isis are very related clearly with Horus and Set, and Geb and Tot at a bit further. The interesting thing is that the system has found something that we already know. So the system is not an Egyptologist, and is not saying strange things, no? We are going in the wood way, it looks.
In the 2D space, which could be more interpretable for us, we see something that is very interesting. We see accumulation of points.
Mm.
This is for further work, and we have to see what means this accumulation, because if possible, will mean that these words are very relation in terms of context and could indicate interesting things. Well, another time we repeat these relations between the points Horus and Osiris, Seth and Isis, Thoth and Geb. If we go to the quantitative results that indicates a numerical results, we can see the most relation words to each one of them. In this case, to Horus, Seth, Isis, Osiris, Geb, and Thoth. And for example, in the case of Horus, we can see that Osiris is the most relation one with them. Here, Carlos, I need your analysis.
Yeah. Here it is a case that is interesting. It's we don't have the diapos in the next one. Yeah, this one. So if you go back to the table, we can see that in Horus, the system is able to relate eye paint, both eye paints, set them and watch. So the black one and the green one, with words like instant, at, the eye, the sound eye of Horus, obviously, Ujat, to blink, and wound. So instantly it jumped to my mind the idea, the Wittgenstein's idea of family resemblance. So the thing in the next, you can see. So the system is relating in some way using those contexts. So the mixed context, all the context in the Mortexvar is using it to relate three semantic spheres that seems related in some way. The first one is the sharpness, like in demi, no, which means basically to be pointy or to be sharp, and then to sharpen the eye. Quickness, which is the art, but also the idea of aggressivity, as we know. So in some way, it makes sense. Of course, this is the beginning of the research, but it makes sense to us as Egyptologists. We can picture the falcon, Horus, doing these things. So the sharp vision, the quickness of the bird, and the aggressivity in the fight with Set. So far, nothing that we don't know, but I insist, the system is a machine. So again, for me, it's of course we have many negative results also, but some of the results are useful Egyptologically. And I remind that we are working with a very partial version of the whole corpus. So we are working with the Mortexvar database, which has 28,000 sentences, only one variant of each style. So it means that we are working maybe with 5-6% of the whole corpus. And also, we don't have all the translations for all the sentences. This is why we, in the Mortexvar database now, has much more transliterations than translations. So I think in the future we can raffinate much more the results, no? The analysis.
Yes. In the second case, if we proceed to make the same process with transliteration, we saw differences between them. For example, you can see that here Get, in comparison with translation, is very near to Horus, which here is very far. It could mean, for example, that from transliteration to translation, we lost some important information that is could impact a lot in our representation. For example, another important thing that we saw is that Isis and Thoth appears too very near, and relations like that. The same in the 2D representation. We saw too is that in transliteration we have a lot of zones with very well-defined density, and we did the same with our transliterations, seeing more or less the same relations, and with another time our scores about that.
Yeah, in this case we have an example with the verb sar, to keep, that we have associated with set related words, because there is one spell, 935, in which it occurs, the officiant other in this verb occurs in that spell, and the officiant is addressing the deceased, this Osiris, and not to the god Osiris, in the well-known context of offering the eye of Horus as a prototypical offering, as you know, and protection to the deceased. Nevertheless, in the previous spell, 934, which is a very similar spell that occurs in the same document, A1C, the deceased is explicitly identified with a god, and then with Osiris in two different manners, in two consecutive sentences. So first, the emphatic mereref of the verb wenen, you are like a god, talking to the deceased, and then with the vocative. Is in that spell, the deceased is addressed as Osiris, do this. So how to interpret this is the thing that set is related to the offering of the eye of Horus in some way. The verb to keep is associated with that god, but the context is the eye of Horus. So apparently, my interpretation is that the system is able to make the match between the key relationship between Set and Horus is the eye of Horus. So in the fight, we know that Horus loses the eye because Set takes it. So apparently the system is able to make through all the 300 vectors in the mixture of context to arrive to the conclusion that the main relationship between the two gods is the eye, which is a very quintessential factor in the Egyptian culture, as we know, because it's the prototype of the offering. No? It's the thing that you do, that you give to the deceased by definition, by defect, so to say.
And we have other sample, well, the sample that you explained.
Yeah.
And after that, what we conclude is that, well, we can represent all our corpus in only one representation that we can interpret in some sense. We can use metrics to measure this semantic relation between these words and expressions, which maybe is interesting because sometimes we can see facts that is difficult to see for the human eye, usually because of the large documents that we have to read. The possibility of the corpus reconstruction, which is interesting because if we have words that are missing, we can use the surrounding context to propose words that could fit in these missing spaces. And finally, the use of and classification of determinatives.
Yeah, if we can combine the first procedure I told you about, the OCR line of research, with this approach, more semantic, we can narrow down the use or make lists of uses, how determinatives are used throughout the corpus. That will be a real improvement in order to interpret what are the possible uses of determinatives in the language. No? If there are classifiers and other things like sensitive to the context, when we have cases where we have verbs with 11 determinatives, for example. So it must be in some way context dependent or not, maybe another. But I think the combination of the two approaches, OCR and the semantic network, can be key to go further with this kind of research.
And after that, we prepare some interactive representation that will help us to visualize this better. We prepared videos because it was difficult to install it here. This first representation is a little chaotic. This represents all the corpus in one 3D representation that is navigable. We can rotate it, we can be near, and other things. So as you can see, if we go near to the center of the cloud, we can see that all of these represent words. All these words are connected in different senses. For example, if we try to see some words that have a lot of connections or links or are very used, we can see what words are and where they proceed. In this case, where are verbs, because it's very concrete. But well, is this usable as this? We have to post-process a lot this because it's very difficult to navigate in this. What we prepare after that was the representation or our specific words, what we think that is more useful. In this case, we have our 6 example words. In translation, you can see that Seth is the red, Osiris is the green one, Horus the blue one, Isis the pink one, Thoth the blue one, but well, lighter blue, and we have Geb here in lighter green. We can see the relation between these words and another words that are used or in contextual terms similar to them in the corpus.
One can even think when you see, or when I see Geb a bit separated from the others, it reminds me the matter that when the problem between Horus and Seth is not settled, they have to go to the tribunal, which is presided by Geb. So Geb is kind of the backup of the action, of the main action, no? And this explains which is farther from the action.
In this case, we did the same theme, but with transliteration and adding more words. You can see that now the clouds are very well relation. For example, Seth and Isis, Isis, Seth, and Thoth, I think. Not all the words are good, so we have to pre-filter that by an expert, but usually help us to see relation. For example, that Geb have a relation that is not strong in this corpus. For example, comparing that to Seth and Isis and other ones.
But you see, this kind of technology is not that we are going to be retiring from Egyptology, us, not at all. We need to interpret all that, but it provides potentially a lot of materials with some sense, and then we can go on with the research. And quickly, more quickly. ¿Eso cuál es? No. Okay, that's all. Thank you. Sí, no nos toca. Estamos acabando bien.
Thank you very much. That was fascinating, really.
Yeah.
Okay. Our next speaker is Giulia de Marco from Medjehu project. Giulia de Marco is a member of the Medjehu project, specializing in the study of New Kingdom woodworks and participating in several archaeological missions to the Theban necropolis. She obtained her PhD in Egyptology in 2020 from the University of Pisa in collaboration with the Museo Egizio in Turin, with a thesis on the New Kingdom woodworking in Deir el-Medina that will soon be published in the series Studies of the Museo Egizio. On this topic, she has also published numerous papers and participated in several conferences. And today, Giulia is talking about the reality of Deir el-Medina wooden objects, from text to material culture.
First of all, I have to thank Fuentes Carlos for allowing me to participate in this inspiring conference, which promotes an interdisciplinary approach to textual analysis, which is precisely the methodology that I've been using in my research in ancient Egyptian woodworking. To address this issue today, I will explore the materiality of the el-Medina text related to woodcraft, with the aim of understanding one of the functions of this text, which is to act as a functional object in the private sphere and within the workshops, and so challenge the old conception of Deir el-Medina woodworking conceived as a side job. In my research, by employing an interdisciplinary methodological approach to textual sources, I was able to expand the research and begin to delineate the true extent of wooden object production, which I will now present using the case study of the wooden objects typologies. First of all, just a brief introduction to the context of Deir el-Medina. This site is located on the west bank of Luxor and is well known in Egyptological studies as it was created to house the craftsmen employed in the construction of the royal necropolis in the Valley of the Kings and the Valley of the Queens during the New Kingdom. The exceptional state of preservation and the unique nature of this site, which encompasses all aspects of a community, from the daily life to the administration, from the religion to the funerary practices, all these aspects have allowed extensive investigation into the numerous aspects of the ancient Egyptian culture. However, research into the local artisanal production remains very limited, in particular concerning woodworking. Despite the absence of archaeological evidence of structures or workshop areas, the abundance of textual references to carpentry and to wooden artifacts, coupled with the remarkable state of preservation of the wooden material culture of this site, allows for a comprehensive reconstruction of this craft sector. The interdisciplinary and comparative studies of different sources that I've been conducting since 2016 has enabled me to challenge the long-held assumptions of woodworking as a sector of minor significance in Deir el-Medina and to offer new insight into its socioeconomic role during the Ramesside period. Carpenters were not only engaged in the royal necropolis construction sites, but they were especially active in the production of wooden goods within the village. In fact, the state administration allowed the private practice of carpentry and its sale on the local market in order to provide the other types of essential goods that the administration did not deliver through wages. This socioeconomic weight in the dynamics of the community indicates that at least some of the woodworkers attested by the sources were professionals who were fully dedicated to this craft sector. If the concept of informal workshop as defined by Cunei is accepted as a system in which Deir el-Medina craftsmen informally cooperated in their free time to create funerary objects for their fellow villagers in order to increase their income, it is evident that this system had to be supplemented by structured workshops to allow the functioning of such an important and developed sector. In fact, my studies have shown that the woodcraft sector involved various professionals operating within a well-established system that allow flexible working methods. In order to understand them to follow the production process, texts play a fundamental role as they testify the intensive production of wooden objects and their circulation. Conversely, the surviving material culture provides further and sometimes different evidence, allowing the understanding of numerous aspects that are not evident from the textual sources alone. The data obtained from the text will be presented here and compared with the material culture. The consistency and the disparity of the sources will be highlighted and discussed in order to define the reality of Deir el-Medina wood production. To carry out a comprehensive study, I examined all non-literary Ramesside texts from the site that made references to woodworking and to wooden objects. So my corpus consists of 384 administrative and private documents written on ostraca and papyri. Of these 283 documents mention 808 wooden objects, and these objects were described simply as personal belongings or were objects commissioned for production, undergoing manufacture, or destined for sale. The totality of the objects can be classified into these categories, which will be analyzed individually just in a moment. But these are the data that so far have represented the only foundation for past research on the socioeconomic aspects of the site's craftsmanship, including the important contribution from Janssen and Cooney. But the exceptional state of preservation of the wooden material culture found in the el-Medina offers a different situation. In addition to the well-known wooden objects held in different museums worldwide, mostly originated from the antiquarian market, during my PhD at the Museo Egizio and working with the Medjehu project in collaboration with the IFAO, I had access also to a more wide range of objects, which being fragmentary, not of high quality, as sometimes we have to be honest, not so beautiful. For these reasons, they are not known, they are unpublished and unknown. So moreover, it is of great significance that the majority of my corpus comprises findings recovered directly from the el-Medina site by the two of the most important archaeologists of the last century associated with the el-Medina, which are Ernesto Schiaparelli for Turin and Bernard Bruyère for the IFAO. I will now start presenting the data obtained from the textual sources, starting from the most numerous to the less attested, and show the different terminology, which, however, will not include textual or philological analysis, as the objective of this study is to consider these documents as a whole, rather than focusing on the text itself. The data will progressively be compared to the preserved material culture, highlighting the differences between the two. So if we start with the textual reference of the furniture, we can find a wide range of different typologies. Very numerous were the beds and the wooden containers of different sizes and functions. Some of these may have been used in everyday activities, while others were specifically crafted for funerary purposes. However, their correspondence with the material culture remains still unclear. Among the material culture, in accordance with the text, we also have different types of seats and wooden boxes and containers. However, as said, it is still unclear which term corresponds to each object, as well as their function. The second most attested categories of wooden objects in the text is the funerary equipment, which is also characterized by a considerable quantity of items, although the majority are coffins and coffin elements. Then we have few mentions of shaktis. We see 6 here, and then one single mention of a group of 40 shaktis. Their containers, and however, the lack of evidence for the other types of grave goods is actually caused both to the fact that we don't know the final purpose of some types of goods mentioned in the text, like for example, the furniture, but also because some terms are still unclear. Differently from the situation depicted with the text, the number of New Kingdom anthropoid coffins from Deir el-Medina is so far very limited. Almost 30 have been identified. However, during the recent work of the Medjehu project at the el-Medina storerooms and in the Carter magazine in Luxor, all the anthropoid coffin fragments found by Bruyère but never studied nor published were just rediscovered. So probably the number of the coffins or coffin elements will increase in the future. A different phenomenon is observed for the shaptis, which are mentioned very little in the textual sources, but are among the most numerous funerary objects in the material culture. In addition, we start to see also other types of typologies, which are totally absent from the text, like in this case. The quantity of wooden architectural elements is surprising, particularly in the case of doors and related elements. With regard to the columns, it is not always evident if they were used in buildings or for other purposes, such as for the boats. Unlike the data from the textual sources, there are few examples of doors or door elements in the material culture, except for an odd category of items, which are the doors locks that both Schiaparelli and Bruyère discovered in large number during their excavation. Among the cult objects, we have so far only textual references to status, differentiating them between male and female. In the material culture, instead, the spread and the use of this category is largely attested. With the exception of status, the other categories were previously little known or even not known at all. Like all this one, they are absent from the text. Concerning the tools, it is known from the administrative text that the tools employed by the workers at the Royal Necropolis site were provided by the state. However, these tools, as well as other implements, were also used and circulated among private individuals. Among these, a significant proportion were made entirely of wood or consisted of a wooden handle. However, it is very challenging to find these tools, especially in private or production text. On the other side, the contribution of the material culture is fundamental to this category because it reveals previously unknown activities such as domestic and craft work, and especially weaving, for which there is no textual evidence but a huge quantity of textile tools. Despite the scarcity of textual references to accessories, two distinct categories of sticks can be identified, and one of a fan. However, in the material culture, despite the fact that such representational objects were mostly limited to a certain social class, fragments of such items are not so uncommon in the material culture of Deir el-Medina. And lastly, the cosmetic implements. It is noteworthy that this category is nearly absent in the text because it does not reflect the material culture. There is, in fact, a significant presence and variety of objects, even if fragmentary, in the material culture. The study we made with the Medjehu project in the el-Medina storerooms has been fundamental to reconsider this category of objects, as we inventoried around 500 previously unknown items. In conclusion, the comparative study of text and material culture is the most comprehensive method of examining the wooden production of Deir el-Medina. However, to understand the reason of these differences between the text and the material culture, it will be necessary in the future to make an analysis of each category of objects. Just to give you an example, take the case of the coffins. Our knowledge is so far limited to 30 coffins, as I mentioned before. But now we have identified numerous fragments that may increase their number in the future. So the difference that we perceive between the text and the material culture is probably only caused by the state of the research. However, the objective of this study is to understand the reasons why the text present this kind of data, sometimes very different from the material culture. And the reason can be found in the materiality and the function of these textual sources. It can be seen that the majority of the recorded goods in the text were objects of significant value. And this involved elaborate manufacturing process or required substantial quantities of timber. These ostraca and papyri were objects that served to record the wooden items of some value in various spheres, so both private and professional. In this regard, they were used by the carpenters and served as a useful tool in the workshops, providing aid in the production process to record the commissions, the production stage, and the selling of these objects. However, when material culture data is integrated, it becomes evident that the woodworking sector was not limited to these categories of objects. On the contrary, it was highly productive in meeting the diverse needs of the Deir el-Medina community, from the daily life to the afterlife. This indicates that the carpenters employed a specific recording system where they kept written records only of the most valuable commissions. Consequently, the majority of the remaining categories of objects were of insufficient value to be recorded in writing. They could have been ordered or produced through oral communication, as they were smaller or maybe more easy or rapid to be produced, or they could have been even ready-made or mass-produced and sold in an open market, as some evidence from the material culture indicates. A woodworking sector developed to the point where it could afford to produce for the open market had to be structured and developed, so not so informally as Kuni suggests, with professionals working in the sector. These were not simply workers from the construction site who produced wooden objects in their spare time. Rather, they were highly skilled carpenters, capable of running a workshop and producing both ordinary and high-quality valuable objects, including items intended for a medium-high clientele. In fact, textual records indicates that they also crafted items for high officials, such as the viziers. And I'm done. Thank you. Thank you
for your nice presentation. And we are proceeding with paper by Veronika Dulíková and Marek Bukáček from the Charles University, Prague. Marek Bukáček is professional data analyst balancing business career with academic research. He applies his technological skill set to understand the needs of given project, gather data, develop methodology, and deliver comprehensive results and present them. He focuses on areas where exact science meets human aspects carrying certain randomness, namely society, finance, crowd modeling, or healthcare. Marek received the PhD at Czech Technical University, Faculty of Nuclear Sciences and Physical Engineering in 2021, and he has been working with Czech Egyptological data since 2017, focusing on the network analysis, various types of modeling, and general data organizing. I'm sorry that Veronika is not with us. I hope she is online or not.
I'm afraid she is not, because she has right now another presentation in Czech.
Okay. Okay. Yeah. Well, I just feel like mentioning that Veronika and her team are really pioneers in applying network theory on archaeological material, especially on Egyptological data. And Prague is in many aspects a really birthplace of social network analysis applied to Egyptological material. The floor is yours.
Thank you for a nice introduction. Actually, recently we have the chance to read your new book. That was very inspiring. So thanks a lot. So yeah, there are many disclaimers to start with. So obviously, I'm not a Egyptologist. I'm not even close. I'm a data analyst. So please be kind if I will say something very stupid. When I'm working with those data, I'm working with IDs and links. So sometimes I have problems just to read the names correctly, but I think it wouldn't affect the presentation itself. So the first one. The second one, please ask questions during the presentation. I think there might be some clarification needed during my talk, so feel free to just start talking to me. And yeah, and this section is in motion, so if you don't mind, I'll walk here. It helps me, so I'll be in motion. The importance of title importance, that's the like some foggy name of the project. Okay, so to start with, a few years ago, one professor from our faculty visited the presentation of Professor Barta, Egyptologist, and he asked him some questions, and the question was good. So Professor Barta asked my colleague to answer the question himself, and the cooperation between the mathematicians and Egyptologists started. And a few years after, I was involved as something like part-time job to this cooperation. So let's say 2018, I started work with those data. And fortunately, last year we got the foundation for 5-year project that we opened with Egyptologists and also with anthropologists.
So we are now trying to combine quite different data, focusing on the Old Kingdom, and use some mathematical tools to get what we can from the data. So far we published a paper how basically skeletal remains can basically can introduce you what was your profession. So we found some specific morphological changes on bones that was specific for the profession of scribes in the Egypt. So it was like a first project, and we have few more ideas to handle. For example, sex dimorphism, how to use just few bones to identify the sex of the person. We are trying to classify titles of basically Egyptians. We are trying to identify the nepotism of titles. We are trying to analyze why given princess married given poor guy, let's say, and so on and so on. And last but not least, we would like to publish online catalog of persons and titles from the old kingdom. So that's our outline for 5 years. But for next 15 minutes, we will just stay with persons and titles. And I'll go more to the detail. So today I would like to present what data we have, basically what we would like to do with the importance of titles, and basically why we are using social networks. And I'll show you a few results that we already have, but it's definitely not completed work. So we start with the math base. That's the treasury of archaeologist team in Prague. For decades, they collected the data about the persons and their titles and other details. They built a database in FileMaker that is program something like Microsoft Excel with some fancy front end. So they prepared the field to feed it with data, and create such cards for people, for families, for titles. And we have now more than 9,000 persons covered by this database. We have links to more than 2,000 titles, and we have the information about some other aspects of the life. So we have information about tombs, about some furniture and decoration and the other stuff. But those data are not completed, and also there is significant degree of uncertainty, as was discussed this morning. Sometimes it really depends on the interpretation of one specific symbol, whether given person was a wife or a daughter, or maybe both in some cases. So so if you will see some fixed results, it's open project, so it may be precise or changed or whatever. And that's why basically I started. So I got this database. I wrote 2,000 rows of code in Python to get their database transferred to something that can be processed by computer, replace a lot of letters by numbers, changing table structures, and do this boring engineering stuff. To start with some processing. So if you would like to cooperate with mathematicians sometimes in the future, you must expect that first year you will do just fine-tune your data for them to understand. So yeah, there is like a big credit that we are still cooperating. So what's next? We can basically make a lot of things, so we have to discuss what we need to do, because otherwise we will spend years just by going through the data. So we decide that we need to detect the shift of power through institutions, that we would like to describe how the infrastructure changed the dynasty to the dynasty. And to do it, we need to understand this dynamics in society on really low level, on family level or personal level, because we have data to do it. So this is like the outline of the project. Second thing, what we need to add a context to some already known hypothesis. It is known that if one person was overseer of granaries, there is a big chance that his son will be the officer in granaries. So we would like to put some maths around known issue and basically calculate those cases and be able to detect them without the previous knowledge. And personally, what I would like to do is to convert some very unspecified phenomena to numbers. So for example, I would like to express social status by simple number. So if one person will have social status 7.5, it will be much more important guy than the other one with social status 3.2, basically. So I would like to develop numbers to basically replace words or just some ideas to be able to basically continue with complex modeling. So what we have, we start with persons. So let's say each circle is one person. We have now 4 of them here out of 9,000, and those are just hypothetical persons, nothing specific. Fortunately, we have some information. So for example, we have mostly sex of given person. Let's say the red circle is representing women, and the blue one is representing men's. We have the titles. We have some of those visualized here. And as Egyptologist, what you can do the information for titles, and you can assign titles to persons. Because we have those false doors interpreted, we can be able to do it. So, and now we have the first social network. It's a network of title assignment. Yeah, we can do more. We can assign some categories to titles. So we know that some titles are administrative, the others are just rank, the others deal with infrastructure. We can develop many categories, and thanks to it, we can let's say color persons. So if this I do it this way. If this guy holds 2 titles from administrative, it can be declared as administrative guy, and so on. So we can basically use the information from one universe to say something about the people on the other side. Furthermore, we have family relations. So those red lines that were added now, they represent family ties. And now we have 2 networks. We have family network and we have person title network. And because of that, we have basically family title network as well. And we can model nepotism because we have now all those stuff linked. Yeah. With basically persons assigned or assigned labeled by, for example, king or at least dynasty, we have some idea about the time. And with the family relations, we have even better idea about the time. Basically, we can see what was the first and what was next. And we have this information for persons, but we can use it because then we can see for any title when this title was assigned to someone. So we can somehow derive that the title was quite popular in mid-5th dynasty, but it almost disappeared in the early 6th dynasty, and it appeared again in late 6th dynasty, for example. So we can use this time information to model some changes in the society. And so what is missing? What can we wish more? Yeah, we need a formula actually. So we don't have the formula now. So we have to work with that. But what more we have another 2 networks. That's the network of person similarity, the blue one, and the network of title similarity. Because when some title is shared by multiple persons, we can say that this title is probably somehow related, those 2 titles. The same if 2 persons are sharing the same title, those persons may be considered as somehow relative. So now already we have 4 social networks to analyze, and we would like to process them as one. So that's why we are basically staying in Python. We used the networks library and a lot of our own coding to develop a social network model that would be handled to combine all those networks to one. Yeah, and then we need some application to compare titles, right? We need to be able to say that one guy is better than the other guy. Yeah, it seems like a dream, but actually we have such application. And I'll start by the end. We have developed this application that will help us to compare the title. This application will be available soon in our web. Now it's just a beta testing. And our idea is that basically we would compare by some arbitrary criteria two titles. And we believe that if we'll generate sufficient number of pairs and then use some algorithms to process the score, we can have the rating of the titles. So let's start from the beginning. If we would try to measure the importance of some title in government or in company, we can get the salary of the manager or the budget of the team, or we can imagine that we have some sort of number that describes the importance of those guys. So then, if you will randomly pick two guys next to each other, it would be easy to say who is winning. So, are there any chess players? Do you play chess? Yeah. So maybe you know that there is some elo calculation. So if two chess players play each other, their score will adjust based on the fact who wins somehow. So we are using this algorithm. So if we have such a match, we can use this algorithm to adjust the score of the person or title according to who is winning. So we are basically using the process the other way. So we are generating pairs. We are asking Egyptologists to basically answer the question which of two titles is more important, and each such a match will help us to adjust the score of given title. So we just do first proof of concept. We have 450 randomly generated matches, and we just check the most important title, and it was Vizier. And the Vizier played just 3 matches in this competition, and still the algorithm picked him as the most important. So the proof of concept was checked, and yeah, we need to find the resources to do 1,000 matches to basically rank all titles in some higher level of detail. So, okay, so this part of the project is somehow prepared. We have to go create the formula how to transfer the title importance to personal importance, to social status. And so we can now use those social networks to model how the social status can propagate. And that's the last part of my talk. Yeah, so you still remember those 4 networks we got at the beginning. So we try to use the information there to measure the nepotism. So for each title, we checked whether guys on the title pairs are from the same family or not. And if those pairs are from the same family, we said, okay, this title basically contribute to nepotism. And we calculate the nepotism rate for all titles in our database. And we picked some interesting groups where the nepotism rate was quite high, and identified three case studies to present here. So the first one, that's the high priest of Ptah. And we have 14 holders identified in our database. Actually, 8 of those 14 are members of the Ptah first family. And you can see some other supportive statistics that are saying that those guys has very good, very strong relation to family, much stronger than relation to other people in the system, and that the relation to the father is even more stronger than the relation to the family. I don't want to bother you with the definition of those fields, but I'll show you the picture, and it's much better than those tables. So basically here, the quality is not nice. Sorry for that. Here, the highlighted persons are the holders of the title. On the right side, you have all titles that are held by the family, colored by categorization, but this family hold all categories of titles, so you can see some good impression from that. But what is important is that we have 5 generations of successes documented here, and those titles appeared mainly in father to son pairs, and you can see that the other family members are not that important. The size of the circle represents the number of titles that are assigned to given person. So basically just the persons who held the title High Priest of Ptah had many other titles assigned, while other family members did not contribute to the family glory that much. As a contrast, we have that there is some detail statistic that you can see that the link to father from mathematical perspective is always the strongest from all the links in the network. Yeah, the opposite example is the servant of the throne case held by Ptahshepses family. Basically, this title was somehow just spread across the siblings of Ptahshepses, and they didn't inherited the other titles. They inherited just the servant of the throne. So the network is completely different. The Ptahshepses is holding many titles, and his sons are holding this servant of throne and a few others. And therefore, the metrics are saying that the sons between themselves are much more similar than basically they are similar to their own father. And it's kind of visible from the network, and it is visible from the table as well. And the last use case here, that's the case of, we are calling it weavers. So it's a title representing some services in basically in a great house. And in this case, 2 families are basically sharing this title for a whole dynasty, basically. And what is very interesting here that those title was shared by men's and women's equally. And there is a case that basically husband and wife both had this title, and this title was inherited by their son and daughter, basically. So it was something like gender invariant that is very special, as you know. And in the second family, the system is relatively the same. So some grandmother hold it as a first, and 2 daughters and 1 son inherited that. But we don't have information about their kids. But we know that the other basically, let's say, grandson and the granddaughter of this mother inherited the title further to the next generation, and so we have like 4th generation information about this title, and even then the family continues. The title is not spread furthermore. So those are like the observations we already did. So I start to conclude the stuff. So you can see that there is a lot of work to do before we will finish the project itself to have some like compact information. But as a side effect, we can highlight some pattern in data. We can help Egyptologists to interpret the data structure and the information there. And we learned something about the spreading of titles and spreading of family importance. Yeah, I'm always I'm too hurrying, but this is quite nice figure. This one showing that Ptahshepses the first was so important that his wife was basically a princess. We have this royal colors here. So we can basically, we are using this charts even to support the other research as this princess wedding analysis and the others. And what's beneficial, like globally beneficial on this project, is that it is completely written in Python, so it can be interpreted in Python as well. So now, when we know that we are searching for strong relations between, let's say, father and son, and we are interested about the nepotism, I can ask Python to go through hundreds of families. Python will do it in seconds, and it will present me a list of 12 families with the same schema. And I can ask the code for any kind of such information, and it will do it for the whole database, including visualization. So yeah, we hope that there will be a lot of things to present in the next conference. So thanks organizers to inviting us here, and I hope we will meet soon again.
Plenty of questions. So our next speaker is Elizabeth Bettles from the University of Leiden. Elizabeth is a researcher who is interested in morphology, ductus, and orthography of hieroglyphs painted by scribes or painters who created text in the royal tombs in the Theban necropolis during the New Kingdom. To differentiate handwriting styles, the archetype paleographic software designed by King's College London is being adapted to cater for the unique attributes of the painted hieroglyphic script. And today, Elizabeth is going to talk about text transmission of the negative confession, BD 125 at Deir el-Medina, human agency in the tombs of TT3 and TT 265. The floor is yours.
Thank you very much indeed. It's a real pleasure to be here at this really interesting conference. My talk examines the literacy level and painting practices of a seshked, who literally in hieroglyph literally means scribe or painter of form, but who I prefer just to call painter rather than the usual term of draftsman. So I'm studying this particular seshked and his writing of a Book of the Dead spell, and I'll be calling that BD from now on to shorten things, because this spell was painted in two contemporaneous burial chambers on the site at Deir el-Medina, the workman's village. My purpose here is to present evidence about how a painter could approach the painting of the same spell, which in this case is this spell, the negative confession, or it's also known as the Declaration of Innocence, BD 125b, when it occurs in two different contexts, and what impact these different contexts might have had on the copy that he was painting onto the plastered surface. I particularly look at the characterization of the seshked handwriting style and the effect of the variability of space which was available to the painter in these two different locations. So here we have the famous Deir el-Medina, where, as you can see, the settlement on at the base of the dry wadi, the Ptolemaic temple at the top right, but on the left, on the western side, with the tombs. The two tombs I'm particularly talking about today are TT 265 right at the top left, and TT3 slightly further down. TT 265 was a tomb owned by the royal scribe Amenemope, and TT3 was owned by it was a stonemason who eventually became chief worker. I'm also going to bring in a bit of TT about TT 290, which is the tomb of Iri Nefer, but that'll be right at the end of the talk. Now, talking about Seshked, in the 18th dynasty, the level of scribal expertise of a Seshked was probably not vast. Well, if you take the tomb of Amenemhat, TT 340, as Dimitri Laborie has shown, that the level of the writing skills of the Seshked was definitely limited. But and the remains of the 18th dynasty in the site are a bit limited as well. But when it came to the early 19th dynasty, in the year 7 of Horemheb, there was a major enlargement of the village. And this carried on in the reign of Seti I as well, until the settlement had 68 houses were for the artisans, the royal workmen who were going to produce the tombs, the royal tombs in the Valley of the Kings and the Valley of the Queens. Now, what happened at that time was obviously they were concerned about having enough painters who were of the better quality, and so 2 men in particular were brought in, probably from Karnak, because their titles are associated with the god Amun, so it's likely that they came associated with the working in Karnak. Pashadu, number 7, he became the chief painter at this time, so in Seti I's reign, and he had 2 sons. In fact, both these men, Pashadu and Pai, produced, carried on their progeny, carried on with the sons taking on the role of their father, learning the scribal, the painting skills from their father, but it seems that it's likely that these men were more skilled than just painting. This Pai, in fact, the son of Ipui, who's a Seshked of Amun, he after a study from recent study from Stefan Polis, the Messi scribe from Deir el-Medina, who's studying hieratic texts written by Pai, suggests that he was like a polymath. He was a painter, he was a scribe, he was an author of hymns as well. So he was a multi-talented person. We don't know so much about Pashadu, but being a chief painter, his skills must have been elevated as well. Now, what I'm going to do here is what started my study for this talk was the fact that some work by Lucia, Barbara Lucia, in the Oxford Handbook of the Egyptian Book of the Dead, said that Deir el-Medina was important because it produced Book of the Dead spells that were not found elsewhere in the Theban necropolis. It was as though this was just a distinct editing center for Book of the Dead spells that produced spells that were different from in length and in content with the others in other tombs in the West Bank necropolis, but their texts were similar and some almost identical, which again is highly unusual. So this progressed my thoughts into how identical and what was the differences sometimes when they weren't identical and what caused those. So I start off thinking, well, there are these examples of the negative confession in 2 tombs that I could get access to. And in fact, in the last season, I was joined by my photographic assistant, Kiki Ferrix when we were working in the tomb of TT3 to document that. So the documentation that has been done in, say, in TT265, the tomb of Amenemope, now that's been complete. It's about every sign has been studied with that, including the negative confession. But in TT3, it was slightly more limited, but as you will see as we go on. Now, I wanted to find out how these two texts varied and why they varied, if they weren't identical. And I was particularly looking at taking the painter's point of view, the man who stood there in front of the wall with his pot and his brush, and thinking, okay, what do I do with this volare, this copy that he had in his hand from evidence from the Theban necropsy, say like TT 87, as Lucia Diaz has shown that there were ostraca produced that actually from a master copy that were then copied. This was the volare that the painter had in his hand that he was copying from onto the wall. Now, so I wanted to study about this, and I wanted to see if, well, of course, what I also had to bear in mind that when I was studying handwriting styles, that no two handwriting styles are the same, as we know, but also within the handwriting style itself of one person, that can vary over in location and over time. So so no conclusion that I come to here is absolutely 100% certain. With handwriting, you cannot judge handwriting in that way. There's always going to be, or the best you can say is there is a strong likelihood that, or there's just a possibility, or, it's unlikely, there's nothing definite about handwriting. So going to the tomb of Amenemope, TT265, Amenemope was a royal scribe. So his knowledge of texts would have been extensive. And this is the north wall that you see here. His tomb is definitely unusual in the fact that you've got huge areas of text. You've still got iconography, as you can see at the top here. So there's beautiful icon, well done. But obviously the area taken up with texts is much greater than you find in many other tombs, obviously because he was a royal scribe. And you see here the Book of the Dead, the negative confession at the bottom here with the white background, and you see the how that has been, in fact, we'll go to that, that'll show better, yes. You can see how it's been designed with the part at the top, the section at the top here, at the top of the above the figures of the gods, that is like the invocation where they are to the particular gods. On this case, normally there are only 42, but on this occasion there's 41. They actually, if you see the column line on the left-hand side, that has been wiped out with extra white paint. So there originally were 42, but he obviously realized that what was on his volare, on his intermediary copy, was only 41. So he had to do a change. Unfortunately, there's been a lot of damage to this wall at this place. I mean, some of it due to animal activity and environmental events that have happened. So there are parts that cannot be compared with other examples because so much has been lost. However, if you take the signs that have survived, then you'll see in this text, then I've been studying of which ones are, well, studying all the signs. In fact, because I've been studying all the signs, then I can say, though I haven't got time to show you, I can say that these features that I am morphological features that I'm showing you are in fact true for the whole tomb, which was actually painted by, I believe, by one man. I can only see one handwriting, but the features purely on the negative confession that I want to show as being distinctive, because later on I want to compare them, but I could have chosen many more than these. I think 10 signs, many more, but these are the clearest that I can show you. And you can see the features on here that, especially when you compare them to the JSESH image, what differences there are, what distinctive features there are, and that I can see on the A1, the seated man, how the arm comes from his chin virtually rather than his shoulder, the raised arm, and how angular the raised arm in the A2 with the hand going sort of to the neck, where the seated god has a beard that's slightly curved up, the face and the neck. You can see the ears of the D2 has got long straight ears and a very thin triangular neck. Also very distinctive. An important one is the mouth, the D21, how that is diamond shape. The forearm, where the hand and in the hand, the D46, and both of them have the thumb actually turning around and touching the hand. And then you've got the length of the ears of the hair and the thinness of the body of the vulture, and the wonderful lapwing, but it lacks its twisted wings, and it only shows one hand, raised arm. So there are so many things, virtually every sign. I mean, there are some that don't have anything really distinctive, but you can really, there are about only 10 of those. Now, what you have now is on that text, I want to sort of tell you about the orthography, or the way. It's not really orthography, it's not the differences of the spelling, it's the way the signs are presented. So you've got here at the top with the interjection, the U at the top, the yod and the M17 and the man with his hand to his mouth. They're all along the top of this the text. But then comes the deity's name underneath. Then you have the verb and the participle, perem, who came out of, and then you've got the place name that he came out from. And you can see the decision that the man made, that for some reason, whether it was his reason or whether it was the reason of the royal scribe, an emphasis was created on the name of the god in contrast to the name where the verb and the place he was coming from, because the signs are bigger, they're more spaciously distributed, whereas at the bottom of this section you can see how they're all cramped together and squashed. So, and that's, unless he was copying his Vorlage like that, that showed that, but I personally doubt that. I think this is, I have yet to see anything similar to that, though. If anybody knows of anything, please let me know if there is a comparative thing to this. Now, that was TT265 of Amenemope. Now we're going to Pashadu, TT3. And Pashadu, this was not the negative confession was not painted on the wall, but was painted on the sarcophagus. In fact, the front wall of the sarcophagus. So you see on the top right there, when the tomb was found in 1834, soon after that, a Scottish artist came, Robert Hay, and he made a sketch of the tomb, so that you can see from that the sarcophagus, which is actually part of the east wall, was still there. It had been constructed from the east wall. It's actually attached to it. Now, when it came to a few decades later in the early 20th century, that sarcophagus had been smashed and was in fragments. And as you can see from the photo in the Museo Egizio's archive. So what happened soon after that? Well, it was that the fragments were taken out, and until recently they were in the Carter magazine, which is near the Carter House. And you can see them all neatly set out there, but you can see there it's in a fragmentary state. Then you have the amazing thing that the ministry asked, requested if they would reconstruct the sarcophagus into the tomb. And that was done just last season in January and February by a Belgian team led by Marianne Rochebeuf, excellently preserved, conserved, and reconstructed back into the tomb. And as you can see, the front of it, that is the negative confession. It's been lost, as you can see, but still enough has remained for comparative analysis to take place, paleographic comparative analysis. But you can also see that this is not the same width. The width of this burial chamber is not the same width as the area of the wall in TT265. So now what you have is, I want to talk about what was going on in Pashadu's tomb as far as the painters were concerned. While we were there, Kiki and I were working in there, we were able to document two other texts, one on the east wall, which was the BD 63, which is the man kneeling, the famous scene of the man kneeling, drinking water in the afterlife behind a palm tree, and then BD 78, the long one, where it's, that is for transforming into a divine falcon. Now, if you actually do a paleographic comparative analysis of these Book of the Dead spells, you can see, I haven't got time to go into great deep, but you can see there are differences in each one. That just for instance, the mouth, you can see how in the sarcophagus, how it's that lovely diamond shape, which that doesn't really come into the other two at all. That and the forearm, the D36, the thumb that touches the hand, well, it doesn't touch the hand in BD 78. In that text, and it's slightly different in the BD 63 because there's an extra indication of the roundness of the hand, so it's not done as a straight line. All of these little things and the hair, the ears of the long ears of the hair on the sarcophagus, whereas in BD 78 and BD 63, it's shorter and the angle's different. So, I mean, I won't go on any more about that, but say that I can say that that is my conclusion. So they were written by 3 different people. So you can see, and you can, so just to show you, you can see the difference in handwriting, even within these hieroglyphic painted hieroglyphic signs. Now I want to show you, to compare between TT265 and TT3, and the handwriting as far the TT3 as far as the sarcophagus is concerned. So that's both of them being, of course, the BD negative confession, and you can see here how similar the handwriting is in these many examples. I tried to show you several to show that it's not just one. Making drawing a conclusion on just one hieroglyph is no good. It might be really interesting, but it's got to be compiled with others to bring all the data together. And with those hieroglyphs and with the others that I'm not able to show for time, I believe there's a strong likelihood that the Szeked, who painted the negative confession in TT265 and TT3, were one and the same. But were the texts the same? The spell was the same, but were the texts the same? And here I am comparing these 2 texts, just columns 34 to 40, just as an example to show you. I must note that the text on the on the sarcophagus is near the floor level. So it is at the painter would have painted slightly differently, because he would have probably been in an awkward position. But I did notice that while the text in the royal scribe's tomb, the formatting of the text before the hieroglyphs were painted, there were marks put in to guide the painter's hand. There were none on the sarcophagus, and the lines drawn, the column lines between the 2 texts were completely, one was really neat, the one in the royal scribe, and one was, definitely just done by hand. He was he's still an expert. He drew lines really straight, but they varied in thickness and thinness. But one thing, the most important thing is that the text in TT265, the columns are much wider. They're over 8 centimeters wide. I mean, that's still quite narrow, but it's much wider than the 5.4 centimeters wide that is on the sarcophagus. So, oh yes, just a minute. What I wanted to say was, if you notice here that there's in this text how the text has been changed, not in the signs that were made, but in how they were put in, because the text, the column was narrower on the sarcophagus. They had to be more spread out, because if you made the quadrats that appear in, say, for instance, which is very popular, doing quadrats in the TT265 example at the top, where you've got the width of the column being wide enough to put in 4 signs, as you can see there with the 3 yods and the H dot. But you can see that that was extended and drawn downwards in the bottom one. They've all spread it out so much more so that he can fit it in as down there rather than across. Now, other things I want to mention of the differences was that he changed certain signs that were a bit more difficult or just didn't fit in to other signs. So, for instance, you can see on the top of the column 35, whereas he is showing, whereas he's talking to the god who came from Bucyrus. Now that was
Elizabeth, I'm sorry.
What disaster have I gone on? I'm sorry. How can I just? Okay, can I just? Let me go to the last one.
Yeah, if you can just go to your conclusion quickly. I'm sorry, we are very late. So
I'm so sorry, but I get so excited. But
I know. Okay.
So what my conclusion is that the same Seshked painted slightly different versions of the spell in two tombs. The texts are so similar that the Vorlage he used could have been the same, but he made conscious decisions to alter the text, in part based on the space available to him on the wall. So the Vorlage could have been like the one on TT265, which he abbreviated to make the text fit the reduced space in TT3, or it could have been like the one in TT3 where he adapted the text to fit the wider columns of TT265. The implications of that is that the Seshked, this Seshked was not just a copyist, he was a dynamic agent in the creation of variability in the content arrangement of hieroglyphs in funerary texts. He had an excellent knowledge of the hieroglyphic language and the nature of its flexibility, so that any changes he made retained the text meaning. So was it Pashadu, as has been suggested? No. That's another question. But I can say that Kiki and I hope very much to document in the tomb of Irinefer in the future, because that has got another example in, and I'm sure we can learn an awful lot from that. And I'm not sure how long I went on, but thank you for ever so much for listening to me. And there we have the team of conservators, what they're doing in, this is the TT265 in the Royal Scribe's tomb, and that's what they're doing at the moment, preparing for the tomb to be opened. And I'm ever so sorry.
It's okay. Thank you, Elizabeth.
Thank you. And our final speaker is Joaquín Jiménez Puerto from the University of Valencia. Joaquín is a researcher in the field of computational archaeology with multidisciplinary training in history and archaeology from the University of Valencia and computer science. His areas of specialization include the study of late Neolithic Chalcolithic through computational methods applied to archaeology, and especially in social network analysis, artificial neural networks, and paleodemographic modeling. He is currently working with artificial neural networks, machine learning, to classify archaeological artifacts and integrate them into social network analysis. So we started with the more specific material, and now we are reaching a more general approach to the network theory and social network analysis.
Hello, everyone. Do you hear me? Do you hear me?
Yep.
Okay. So first of all, I would like to express my sincere gratitude to the organizing committee of this Congress for this kind invitation. I must admit that coming from Iberian prehistory to Egyptology feels a bit like moving from black and white TV to full color. The richness of your historical and textual sources is truly impressive for someone used to working with fragmentary evidence. However, sometimes having fewer pieces of the puzzle forces you to develop interesting ways to connect the dots. As a researcher in Iberian prehistory, I found social network analysis, or SNA, to be invaluable for understanding patterns of interaction in the archaeological record that weren't immediately obvious through traditional approaches. This analytical tool has helped me understand how different elements in past societies connected and influenced each other. Today, I'd like to share some approaches that have worked in my research, not because they are revolutionary, but because they might offer interesting perspectives for your work. I'm particularly eager to learn how these methods might be adapted to the rich complexity of Egyptian archaeological and textual evidence. Think of what I'm about to share as adding another tool to your analytical toolkit, one that might help illuminate the intricate web of relationship that made ancient Egypt the fascinating civilization you study. One moment. Yeah. Let me explain what SNA actually is, using something very familiar to all of us. When you study a tomb's decoration, you're not just looking at individual hieroglyphs, you are looking at how they relate to each other, how they form words, how these words create meaning. SNA works in a similar way. It's about understanding how different elements connect and interact within a relational framework. In its simplest form, SNA looks at two basic things: nodes and connections. Nodes could be anything: archaeological sites along the Nile, different temples within a complex, or even specific types of artifacts found in tombs. The connections are the relationship between these nodes, such as trade routes, shared architectural features, or similar artistic styles. This relational framework is key because it shifts the focus from isolated elements to the broader system of interactions and dependencies, allowing us to study ancient societies in a more holistic way. What makes SNA particularly useful is that it can help us identify patterns that might not be obvious at first glance. For example, just as some hieroglyphs appear more frequently or in key positions in text, SNA can show us which sites or artifacts played central roles in ancient networks. It can reveal which locations were crucial connection points, which styles of pottery traveled the farthest, or which temples had the most extensive networks of influence. Moreover, through this relational perspective, we can uncover emergent effects. That is, unexpected properties or behaviors that arise from the complex interplay of connections within the network. These emergent effects might help explain cultural shifts, economic changes, or the spread of particular innovations. But perhaps most importantly, SMA gives us a systematic way to test our hypotheses about these relationships. Instead of just saying this seems to be an important site, we can actually measure its centrality in the network. Instead of just noting that two regions seems connected, we can quantify the strength of that connection through the archaeological record. By incorporating the relational framework and focusing on the patterns and emergent effects within these networks, SNA provides a powerful tool for uncovering the dynamics of ancient societies in a way that was previously impossible. By integrating concepts like social complexity, resilience theory, and the adaptive cycles model, SNA enables a deeper exploration of how interconnected systems respond to stress and change over time. Artifacts serve as tangible markers of complexity, offering insights into shifting social dynamics and the adaptability of ancient networks. This approach highlights not only the structural properties of networks, but also their capacity for transformation, revealing moments of innovation, reorganization, or decline. Linking these ideas with cultural evolution allows us to trace how iterative processes of adaptation and selection shaped societal trajectories, providing a nuanced understanding of how cultural and material networks co-evolved within their environments. Now we will take a look at some key applications of SNA in archaeology through research examples. First, SNA can help us understanding transmission of information and cultural patterns. By analyzing how different artifact types or styles spread through space and time, we can identify key nodes in transmission networks and understand how innovations moved between communities. Second, SNA proves invaluable for studying social complexity emergence. Multiple network types can be analyzed simultaneously: exchange networks, resource access patterns, and social interaction networks, revealing how complexity emerges through interactions at different scales. Third, SNA helps us understand trade and exchange. Through network analysis, we can identify key trading hubs, understand how different regions connected, and measure the resilience of these connections over time. Looking at linguistic patterns, SNA offers powerful tools for studying written traditions and their transmission. We can analyze text patterns and variations, map relationships between different traditions, and understand how writing practices evolved and spread through ancient societies. What makes SNA particularly valuable in archaeology is its ability to work with fragmentary evidence, reveal patterns not visible through traditional analysis, and integrate multiple scales of interactions. Also, tracking changes over time, and finally combining spatial and social relationships. Network analysis of the third millennium before Christ in Eastern Iberia provides an excellent case study of societal transformation. This period marks a crucial transition from late Neolithic to Bronze Age societies in the Iberian Peninsula, characterized by the emergence of social hierarchies, visible in differentiated burial goods and the spread of the bell-beaker phenomenon across Europe. These social changes and their effects on different aspects of society become particularly visible through network analysis. First, we start with material culture data. In my research, I developed a comprehensive database that included different categories of artifacts. They were divided into ideotechnic objects like idols and ornaments, weapons and tools, both lithic and metallic, and different types of pottery. There were, I think, more or less 200 of different items or typologies. The key here is selecting artifacts that are meaningful for network analysis. We need items that have sufficient frequency in the record, show formal diversity, are representative of specific chronological periods, and have well-established typological classifications. Once we have our material data, we calculate similarity indices between sites based on shared artifact types. This is crucial because material culture similarities can indicate social relationships between communities. We are essentially using material culture as a proxy for social connections. The similarity values are then transformed into adjacency matrices. Think of them as tables where each cell represents the relationship strength between two sides. From these matrices, we can generate network visualizations where nodes represent archaeological sites or levels, edge connections represent material culture similarities, and edge weights indicate how strong these connections are. Then we apply various network metrics to analyze different aspects at different scales. Structural metrics at the macro level, community detection at the intermediate level, or individual node metrics at the micro level. At the macro level, structural metrics like density helps us understand how interconnected a network was overall, such as whether a society's trade system was centralized or decentralized, shedding light on its organization and resilience. At the intermediate level, community detection methods like modularity identify smaller groups or clusters within the network, such as regional trade group or cultural groups, revealing localized interaction. Finally, at the micro level, metrics like between centrality highlight key nodes, such as important settlements or artifacts that act as bridges connecting different parts of the network, showing where influence or innovation flowed. These tools together allows us to explore ancient societies in a more systematic and detailed way. If our data include geographic information, we can map them to analyze how they relate to their geographic context. For example, as shown in the slide, different time windows can represent the state of the network along a diachronic axis, providing insights into temporal changes and connections. This methodology enables the quantitative study of ancient social structures through material remains, where distinct artifacts illuminate different social dimensions. Information flow through technical knowledge, exchange networks through traded goods, and social organization through ritual objects. In my research, comparing these various networks has revealed how multiple social processes operated simultaneously, yet responded differently to external stress, offering a nuanced perspective on the dynamics of ancient societies. Different type of network analysis can reveal distinct aspects of past social dynamics. In this research, I combine multiple analytical approaches to understand social connections in Eastern Iberia. First, a structural network analysis on the network level, metrics like density and clustering or modularity revealed overall connectivity patterns and stability, while path length analysis shows how efficiently information could flow. By tracking these metrics over time, we can identify moments of crisis and stability. Second, comparative network analysis was conducted by analyzing different types of networks separately. Lithics, for instance, metals, and pottery. We can see how different social processes operated. For example, L-beaker networks showed clear tendency from homogeneity to fragmentation. Meanwhile, information networks tracked through lithic arrowheads were more sensitive to change. This comparative approach reveals how different social mechanisms operated simultaneously. Third, in a multiscalar analysis carried out, we could find that at the macro level, we can see broad regional patterns. At the meso level, community detection algorithms reveal cultural boundaries. And in this slide, we can see here the evolution that crystallizes on the algaric sphere on the south, we can see in yellow, and the bronze Valenciano on the north in red. At the micro level, we can extract information of individual sites by analyzing metrics such as betweenness centrality, which identifies key nodes that connected different regions. In these maps, this is indicated with the size of the node. This multi-level approach helps us understand how local interactions created large patterns. These analytical tools can be adapted to study various archaeological contexts and questions. Whether you are interested in trade networks, cultural transmission, or social complexity, SNA provides powerful ways to extract meaningful patterns from archaeological data. Finally, SNA was used in my research to quantify social dynamics and adaptative cycles in archaeology. And all of this under the umbrella of resilience theory paradigm. When applied to the data, these tools reveal 3 complete adaptative cycles in Eastern Iberia during the 3rd millennium BC. This allowed us to precisely identify transition points between phases and measure the intensity of social reorganization. To conclude, sorry. Sorry. Yeah. To conclude, I will highlight how these analytical approaches have the potential to enrich research in Egyptian archaeology. First, SNA multi-scholar approach is particularly valuable when dealing with complex hierarchical societies. It allows us to simultaneously analyze relationships at different levels, from local interactions to regional patterns to long-distance connections. This ability to move between scales while maintaining analytical coherence is especially powerful when studying complex state societies. Second, Egyptian archaeology's rich combination of textual and material evidence offers unique opportunities for network analysis. SNA can integrate different types of data into a single analytical framework, allowing us to examine how material and textual networks interacted and influenced each other. Third, quantitative tools could provide new ways to measure and understand social and political dynamics. By quantifying network changes over time, we can track patterns of centralization, fragmentation, and reorganization with greater precision. What makes this especially promising for Egyptology is your rich contextual knowledge. While in prehistory archaeology, we often work with fragmentary evidence and limited context, your field's deep understanding of historical, social, and political context would allow for much more nuanced interpretations of network patterns. The combination of SNA analytical power with your detailed contextual knowledge could offer profound new insights into ancient Egyptian social dynamics. I look forward to hearing your thoughts on how these methods might be adapted to your specific research questions. learning from your expertise in applying them to your context. Thank you very much for your attention.
Thank you very much. We have something like 40 minutes for discussion, or a little bit less. Okay.
Yeah, as we are a bit late.
Yeah.
If you're okay, we can keep 15 minutes question in priority for the people online, as we will be together then. So, but if you have any question now, feel free to take, and then we will go to the demonstration. So.
Yeah, that's
Yes, and any question for Geoffrey Killen, we can do it in the demonstration. He will be happy to answer to you there.
yeah. So, any question for the audience? Yes, please.
I have a question for Elizabeth. Bettles. Don't know if you. Yeah, I think you're still with us. Can you hear me?
Yes, I can. I can.
Yeah. So,
Oh, there's a
yeah.
bit of me. Yes.
Thank you very much for your presentation, which I really enjoyed. I had a question regarding TT265. I mean, yeah, TT265. And I wanted to ask you what you think of Bruyère's hypothesis that, TT3 and TT 2019, so the tomb of Nemet Maat, could have been done by a Seshked named Mena. And if you had looked into that, because some of the scenes in TT3 are very similar to, not talking much about the text, but the scenes are very similar to the one in TT2 19. And I was just wondering if you had made connection between the two tombs you are looking into and also the tomb of Nemet Maat in the el-Medina.
Well, first of all, I'm a bit uncertain about comparing tombs through iconography, as though the Seshked might have painted both iconography and text. I think in certain tombs, it's certainly the case, like in the tomb of 20th dynasty tomb of Ancherkawi, yes. But when it comes to painting similar scenes, and my thought is that in there's one of the bit I missed was Gemma Menendez has suggested that the painter of 265 was the same as the one who did Senedjam. And she did this on comparing by iconography, but I can say from the paleographic point of view, I don't agree with that. That's, you know, and I think with 219, I haven't seen the similarity. All right, I haven't made a detailed study of 219, but I have been into 218, and that interests me. The BD 78 text there, the Divine Falcon, in 218. Ooh, the hand looks so much like in TT 265. So I think on that occasion you can't base a comparison and say that the same Seshked did in 2 different or 3 different tombs based on similarity of iconography. You've got to you've got to study the hieroglyphs and yeah, I mean, yes. So that's, I could say much more, but I won't go on.
Yeah, I mean, it's just that it also can be 2 different things, because we know from other Theban tombs that you can have painters who do the decoration and scribes who work on the text, and those sometimes are not the same. And then you have tombs where it might be the same person who did both.
Yes.
So, yeah.
Yes, but not all the time, you know.
Okay, thank you. Any other question for the people online? May I put a few sentences, somehow taking the opportunity and privilege of being chairwoman? Yeah, we heard a lot about network analysis, network approach, social network analysis. Nowadays, people are talking about historical network analysis also. And it may look really as a magical tool. Suddenly, everything is possible. It may be, but usually it's not. Because, yeah, what we are doing is absolute nightmare for any decent sociologist. So we are working with fragmented data. I don't know whether my material is 10%, 20%, 50 or 80% of something which once was complete picture. The second point, we cannot control material we are using. We do not have control parameters, which are also essential for sociology and for any type of measurements. And the third very important aspect is a temporal disbalance. I cannot control it temporarily. If I have 4 generations on Stela, okay, technically I may know how many years this is, but I don't know whether the grandfather was alive in a moment when the object is settled. So many obstacles. And in many cases, what we are having as a final result is just a snapshot of the past and very often very distorted. But the visualization which we had with Luisa and with Carlos is fantastic. With traditional approach, we cannot see all this fantastic aspect of our fragmented and most probably distorted world. And this is very, very important. So somehow, at least my approach is, it's not method per se, yeah, but combined with traditional approaches, we really can see a picture anew. So thank you.
Yeah.
There is a question.
Yeah, just a small remark to the points you just made is that one of the main importance people need to remember with network analysis and the like is that this is a tool to give you an idea of where do I need to look. These networks are not the end, they are the start of your work. And that is sometimes lost in translation when we talk about it. So
I agree completely.
Any other question?
Yep. No?
No.
No. Okay.
Sure.
So, thank you very much. I think this session is very successfully concluded.
Thank you very much to all of you.
Thank you.
Say something? Okay. Thank you very much for coming to Alcalá and for staying, no escaping, and for your contributions mainly, and also for the wonderful couple of days we had, very convivial and new friends and fellows, and I hope that we will keep these conversations in the future. All of us, part of us, 2 of you, or 3 or 4. So this is the beginning of another network of about the relationship between the writing and the materiality of things, no? And I think it's a really important approach what we could do here.
A network going to China, because thank you everyone online also. I don't know which time is it, Luisa, there, but everyone, thank you so much.
It's almost 2 in the morning.
Oh my God. Okay, go to sleep. Go.
So clearly we have go. Okay.
Thank you.
So we go to the School of
Thank you so
Architecture.
much.
Thank you.
Bye-bye.
Thank you.